Good morning, students. Let's settle down.
Good morning, sir.
So we have Manan, we have Shubhankar, we have Nandini, we have Gulshan. Shubhankar, you have college, right? How are you joining the class?
Sir, I have college from 10:30.
Oh, online, offline?
Offline, sir.
So how are you? Are you not traveling?
Yes, sir. Yes, sir.
Yes, what?
Sir, I'm on the bus.
Oh, okay. Very nice. Very nice. Okay. Good morning, students. So we have Manan, Nandini, Gulshan. Let me know, students, if you can hear me.
Radio 5, Victor Tango Mike Alpha November.
Radio 5, Victor Tango, November, Alpha November.
Very good. Nandini, nice to have you in class. Manan, nice to have you in class. Shubhankar, same. 1 second, okay? Let's just settle down. We'll get started in a couple of minutes. Take it easy, everyone. Students, give me a minute, okay? Jyotsna and Rishi are also joining in. Okay, welcome back, students. Good morning, everyone. Welcome to the class. We also have Suchita and Yukti joining us. Yukti and Suchita, do a readability check. Rishi and Jyotsna, good morning. Welcome to the class. Please do a readability check, everyone. All students who can keep their videos on, please do so. Especially students who have just started working. I just would like to see and observe how everyone's doing. Also, students who are preparing for their navigation exams. So I think, Manan, you have your exam coming? And anyone else having exam in this month for navigation? I think Nukul is not joining us. Okay. So, Manan and Nandini, for you, the instructions are very simple. What we are supposed to do is that for you, the whole motive is to do a thorough revision. Okay. A thorough revision, completion of fundamentals, and making sure that you are ready to clear your exam no matter when you give the exam. So now we are going to brush up and finalize your preparation. All right. So make sure that you follow the strategy that I'll be giving you all plus your self-study strategy for navigation. Students, there's no one who's having the video on. At least couple of students try to keep the videos on. If you don't have privacy issues, Jyotsna, good morning. Suchita, very good morning. Welcome to the class. Yukti, very good morning. Welcome to the class. Students, talk to me. You can talk to me through verbal responses and you can drop me messages in the Zoom chat box. See, I'll send a message to everyone and you all can just reply and converse and keep messaging, keep talking, keep replying via chat also if you don't want to disturb me talking in between. Good morning, Suchita. I've got your message. Gulshan, I haven't heard anything from you. Are you there? See, it has to be an interactive session, students. Okay.
Good morning, sir.
Very good morning. Very good morning. So everyone, one by one, just let me know your presence nicely and say something. Are you ready to get started with your navigation classes? Maybe for the first time, maybe again. Some of you all for the first time, some of you all obviously revision, and some of you all are in between completion, right? So, yeah, please go ahead one by one, everyone. Just good morning, read you 5, and yes, I'm ready to crack navigation. And end with your call sign. Students who don't have call signs, don't worry, you'll be getting call signs very soon. Okay, one by one, please talk. Let me know. Let's establish that everybody is in connect. All right. Our rate of speech is matching. I can hear you. You can hear me nicely. So I want everyone to talk. All right. Say anything. I've given you a few points. Make sure I can hear you for about 10-15 seconds. All right, students, one by one, anyone can go first.
Good morning, sir. Video 5, ready to get navigation plan. Cricket Tango Juliet entry of
Victor Tango. Station calling, Mumbai ground. Say again, call sign.
Victor Tango Juliet Yankee Oscar.
Victor Tango Juliet Yankee Oscar. Good morning, Jyotsna. Welcome. I like the energy in your voice. Volume is low, but the tone has the intent and it shows that you are very happy to get started again. Very nice and very good, Jyotsna. Very nice. Keep it up. Welcome once again. Next, who's going next?
Good morning, sir. Radio 5, ready to crack navigation. And Radio Victor Tango Michael for November.
Very nice, Manan. I like the hold in your voice. Very good. Keep talking. Manan, mainly for you, a lot of acknowledgement will be required in these sessions. All right. Nandini, for you also, because this will be a final brush up for you all. Okay. Today's session is just a combined session for all because beginners also, freshers also, I wanted you all to get started with your live sessions. So you'll be learning here also and others you'll be revising also a lot of fundamentals which are important. Talking about Rishi, Jyotsna. Okay. And Suchita, we can consider Yukti, Suchita, Gulshan, Shubhankar, you all to be in the same zone. So if you're thinking who's a fresher and who's not, so Gulshan, Shubhankar, Yukti, Suchita, you would apparently be in one batch. All right. Fresh batch would say where you'll be leading with lecture 1, lecture 2 and all. Obviously, today you'll be learning something. The first few lectures are always covering up everything about basic fundamentals of navigation. All right. So you'll be seeing that as you move ahead, slowly a few more people will be joining in together. And you might not have Jyotsna, Rishi, Nandini, and Manan in future classes with you because their classes might be separate because they're already done with a lot of topics. Sometimes you'll be having a combined class. Sometimes you'll have only your batch class. Talking about access to offline lectures in case you miss attending a live lecture or in case you want to revise. So the access right now, this lecture link I'll share with you all if you all want so that you can access it later. Although I don't think it would be required, but still we will upload lectures in proper playlist. So I think this lecture will go in all playlist, F22 also, and the Z class also, and the new batch also, because these are fundamentals and we cover fundamentals multiple times. Okay, so you'll be given a name, especially freshers. You'll be also given a name, a batch name for every subject, so that that can help you keep a proper track and progress. Simple. So whatever we've learned so far, watching recordings or navigation recordings, this and that will come in handy. I'll make sure that doesn't go in waste. That being said, everything is going to be taught and trained and studied in a fresh way once again. Now talking about Jyotsna and Rishi, I think um, I think Hardik has decided to go for full-time graduation from our batch. Okay. So I don't think he'll be doing aviation for now for some time. I'm trying to see if he could study side by side, but I think they'll be going for a full-time graduation. So maybe they'll be doing it later. Talking about Lakshya, I think Lakshya is not available. Harsim, I'm not sure. Sordip, see, he said he'll be joining today, but he's so what I'm trying to say, students, there'll always be challenges to attend lectures on time and regularly, especially when you are at the comfort of your house. So make sure if you have the time, you try to follow the schedule and attend live lectures only. In case you don't have time, now and then depend on recording. Just don't make it a habit. But yeah, for students like Shubhankar who are working, who are doing engineering full time, for you, don't worry, a good combination of online, offline, every now and then, keeping a track of your individual growth. So do not worry about it. But yeah, whatever you need, students, let me know. And that being said, who's going next after Manan? Please continue.
Good morning, sir.
Very good morning, Nandini. How do you read?
Good morning, sir. I can read you perfectly fine, and I'm ready for attending the live lecture. Victor Tango, November Alpha November.
So Nandini, about your computer number, when did you reapply again?
So I think yesterday only, day before yesterday.
You think you have done the right thing?
Yes, sir.
Okay, good, good, good. Okay. And even Achal is not there in class today. Nandini reminded me of her. Okay, so no problem, Nandini. Nandini, we have a lot of doubts, so make sure we'll be discussing them in these sessions. Probably a few doubts today, or maybe when we are doing those related topics to PNR and all, which we are discussing. So make sure those doubts are not left undiscussed. Okay, Nandini? And make sure we have the same energy. Very nice. Welcome to the class, Nandini. Who's going next?
Good morning, sir. Yukti Verma this side.
Good morning, Yukti.
I can read you 5, sir, and I am ready for the live class.
Very good. Welcome to the class, Yukti. And Yukti, you know how to do it. You study, you make your own notes. You'll be making a separate notebook for each topic, each subject, and you will log in all your notes date-wise in sequence. So this goes to Gulshan also, Shubhankar also, and Suchita also. I think Suchita also knows. Gulshan, for you, instructions are that you make sure that you make notes, whatever you learn, whatever I show on whiteboard, and try to make it nicely read, study, understand. When you make notes, when you read, and when you listen, and when you speak, you're using 4 of your 5 senses. So the body tends to register the knowledge more prominently in the first go so that you remember it and retain it in the long-term memory for a long time. So see, what is our task again? Let's remind ourselves our task. Why are we studying? We are studying to give a theory paper. What is the point of giving the theory paper? The theory paper will have certain questions Okay, what kind of questions? Questions required by the government to be studied by DGCA, to be studied by DGCA CPL aspirants. All right. But why written exam? Is the pilot going to fly written flights? No, no, no. It's not like that. It's theory. Theory is very important. The theory cannot be taught during flight training. That's why the theory is taught in ground training. If the theory would have been able to be taught in flight, then we would have not had ground studies or classroom training. All right, got it. But then what kind of questions will I get in the examination? And is it easy to crack? Of course, it is easy to crack. But the point of exam is to check your knowledge. Simple. Sometimes as a student, when we grow up, we think that we have to just memorize answers and give those answers. It's not about that. Exams are not about that. Exams are all about knowledge. And more than anything else, aviation is an example. Just like coding and design and nautical design, and scientific calculation, scientific ventures, math, all these things, they go physics basically. Everything, every machine that you see is first made on paper, something that is called as blueprint. So what you're doing in CPL theory, navigation, this and that, NRT and everything, it is nothing, students. It is just a blueprint to what you have to do in the sky and how. So you make sure that again you reshift your focus. If it has been, deviated, your focus should be knowledge, so that no matter what question is asked, if you are covering your knowledge on all topics mentioned in the syllabus, then you will never miss out on passing, because 70, 75, 80, 70 is passing, right? 70, 75, 80 will be easy for you, very easy for you. So remember that today, whatever you're going to learn, for some of you all, it will be revision. For some of you all, it will be a new thing. Take it easy, learn as much as you can. The strategy is such that the beginners would start easy, small, in bits and pieces, learn a few basic fundamentals, and other students, Rishi, Jyotsna, Manan, and Nandini, for you, it will be a complete revision of your fundamentals. So for Rishi and Jyotsna, it's very important that whatever we are learning, if it's new, of course, you learn. If it's something that you have done, then make sure this is the last time you are preparing for this topic and point, and it is so thoroughly registered in your mind that during exams, even if you don't revise, still you should be able to give the correct answer. Got it, students? Okay, so only Rishi is saying yes. When I ask something, when I'm looking for an answer, either give me a thumbs up using reactions on your Zoom app, or you can verbally say yes, no, maybe. Okay, but I'll need some acknowledgement. Otherwise, an interactive class, how is it interactive if you are not talking, only I'm talking? Gulshan, Nandini, Suchita, no acknowledgement. Okay, Gulshan and Nandini, any acknowledgement? Okay, Nandini is here. How about you, Gulshan? Check out reactions in the Zoom app. So very nice, Yukti. Welcome to the class. Who's going next? We have Shubhankar, we have Gulshan, and I think we have Suchita and Rishi. Come on, quick, students. Let's get started.
Subhankar here.
Yes,
Sir, I'm ready to go for the
welcome.
classes.
Very good. But Shubhankar, how will you make notes riding in the bus?
Sir, no, I am now in the classroom. I have entered the college in a
Okay,
classroom.
very nice. I hope you'll not be in trouble.
No, sir, no. Sir.
But you will learn a little now, and then a little you will learn in the evening. Is it okay?
Yes, sir, my second class is cancelled today. 12 to 2.
Okay, no problem, no problem. Anyway, we have a short session today. But very good, Shubhankar. See, if it works for you. Otherwise, if it's 50-50, then you will have to restudy the session again. Make sure we don't multitask while studying. Otherwise, your knowledge would only be half. So you don't have to worry and struggle and trouble yourself to do two things at the same time. take it easy. Even if you don't attend, if you have time right, like now, even if you don't attend, you want to spend time in your college with your friends before your classes start and all, it's okay. Don't feel guilty about it, okay? Because we are assuming it's your college time, so you'll not be able to attend. But if you're attending, it's well and good, you know. I think it's just nice. Got it? Clear
Yes,
instruction?
sir.
Okay, no complacency. Okay, make sure, because I've seen students who are working or who are studying, sometimes they're even attending lectures while driving the car because they don't have time. Okay, and what I've realized is, although I appreciate the passion, but if you want to do such studies, you do it for revision, not while learning something new, because then half of the time you're focused on other things that you're doing, maybe driving or maybe something else. Half of the things you will understand, then your knowledge is half, and half knowledge is fatal than no knowledge at all, especially in aviation. It's better to say, no, sir, I don't know the answer, instead of giving a very silly and a wrong answer. Like if I tell you that what is a VOR? So you'll say, you know, okay, you must have learned it how. I'm just saying, I, as a student, let's say I'm multitasking, okay, and I'm saying, okay, VOR, very high frequency omnidirectional range. And then I like very high frequency is used for voice communication. So VOR frequencies are used for voice communication. Now, this is a very silly answer. My first line was correct, but afterwards I don't know what it is. So I made a calculated guess, thinking, okay, VHF could be communication for a long range or all ranges. That's a wrong guess. And in aviation, when you give wrong information, they will be afraid of you. They'll be like, oh, you are more prone to make mistakes. If you don't know something, then you'll not make a mistake. But if you know the wrong thing, only then you'll make the mistake. So that's how it is. So always be careful, students, about this also, especially Manan. Manan, you have enough time to complete navigation. I want you to have first priority on navigation, quickly get done with it. Other subjects that you have chosen, will keep it on second priority. Are you with me on this, Manan?
Affirm, sir.
We'll try our best for everything, but first priority on NAV. Okay. That's it. Because you have been working so hard for NAV, I don't want it to go to waste. All right. You have to work a little more hard for regs and met. So I'm saying, even if you don't clear, we have time because we have to finish studying and all. But make sure navigation first priority. You have to clear navigation. Are you getting it, Manan?
Affirm, sir. Affirm.
You are good at it. All we need right now is to assure ourselves. You will assure me. I want you to assure me that all that you had studied, you still have refreshed, and whatever your doubts you have, you will be solving them. Students, for your exams also, you will be getting personalized attention and guidance and revision. So don't worry. This experience is just gonna help you. I like my freshers to see everything that is in store for them when they start. All right. So I think Jyotsna and Rishi, if you remember the first lecture of navigation, we thought about almost all topics that we are going to study and basic fundas of what would do, does what does what does what. Very nice. Shubhankar, nice to see your dedication. Welcome to the class. Now, who's going next? Gulshan, Rishi, Suchita.
Gulshan here, sir. I read you 5 and I'm ready to attend live lecture.
Is it your first live lecture, Gulshan?
Yes, sir.
Very good. How do you read?
Sir, I read you 5.
Very good. Welcome to the class, Gulshan. Let's get started. Remember,
Thank you so
freshers
much, sir.
and seniors and middle seniors, all of y'all will share your notes either in PDF or JPEG. PDF would be better. Whatever notes you make today after the end of the session. All right. Now I have sent a message to everyone. All stations, reply to this message. Yukti, Shubhankar, Manan, Gulshan, Nandini, Suchita, Rishi, Jyotsna. So I think Yukti, Suchita, Jyotsna have already sent me messages. So if you all don't send me a message, it's okay. Other students, please send me a message. I want to see if everybody is able to send message, because in the message box is where you'll be submitting most of your answers, live answers that we'll be solving in class. Good morning, Rishi. I've got your message. So Rishi, Suchita, Yukti, and Jyotsna, I've got your messages. Shubhankar. Shubhankar, it's read you. READ, read you, not radio. Corrected, Shubhankar. Okay, I've got
Yes, sir.
Nandini also. Who's pending now? Manan also. Good. Manan, I know you're a senior, but no laziness. Make sure no laziness gets into you while doing any hard work required. Okay, you will give as much dedication as you were giving when you just started learning. Make sure, okay, no complacency. One short navigation we need. Simple. Very good. So, very nice, Gulshan. Welcome to the class. I know you've been waiting. Very nice. Who's going next? Rishi, Suchita.
Good morning, sir. Radio 5, and I'm ready to attend live lectures. Victor Tango Romeo, India, Mike.
Good morning, Rishi. Rishi, where's the energy? Building it up?
Yes, sir.
Very nice. Build it up. Very nice to see you early morning. And Rishi, you also make sure these points, whatever we are learning, if it is something that you've already studied, it means this is the final prep you should mentally do on that particular topic. And students, remember, I don't have to ask again and again if you have any doubts. You think if you have any doubts and discuss them directly with me. Okay. Very nice, Rishi. Welcome to the class. And I think, Suchita, you're the last one to go. Please say something.
Good morning, sir. Radio 5.
Very good morning. Radio 5, Suchita. So, Suchita, is it your first? How many live lectures have you attended?
Sir, 2 or 3 maybe.
For, I think we did what? Editor instruments?
Yes, sir.
Very nice. Very nice. So, you know the drill. Make sure that you send me a copy of notes and everything after the class. Okay, students. And Sushita, welcome. Sushita, well done on your MET test. Jyotsna, you had also scored very well. Suchita is also scoring very well on your MET test. Manan Nandini, not Nandini, Nandini is doing now. Manan, you had already given those MET tests earlier. You had also scored well. Very nice. Rishi had also scored decent. Rishi, you've given all MET tests, right? 5 of them.
Yes, sir.
Very good, very good. So students, whenever you'll have any doubts, your tests, assignments, lectures, so the last page of your notebook, basically, see, your notebook is going to be a key in your revisions and all. So if this is my last page, right? See, so what do we do? Second last page over here, we write it a parking bay, parking stand, or parking lot. Like cars are parked in a parking bay, parking stand, planes are parked in a parking bay. We park our doubts here. Okay. So you write it parking day, parking bay, or parking lot. Write today's date of the lecture. So I'm calling it Fundamentals Lecture 1 for now. Okay. Navigation. I'll share the screen with you all. Fundamental Lecture 1. Later on, if I'm arranging it in a sequence of series or playlist or a batch, then I'll inform and I'll give it a name. But right now, what will you do? Write today's date. That is very important. Okay. And in the parking lot, you will write the date, lecture date, and whatever doubts you have, just make sure the doubts you have mentioned here so that you can discuss with me and don't forget it. Always remember that. Okay. So, Suchita, welcome. And let's do it, students. Let's get started. The first thing that we're going to see is going to be a relationship between the most important element in navigation, which is basically our Earth and how to navigate on Earth. Okay, so we are calling it Fundamentals 1 right now, Lecture 1, Fundamentals. But the naming and all for playlist later. Right now, let's just focus on this. So what am I talking about right now? I'm talking about Earth and directions. For some people, Earth is very complicated. Directions, they don't emphasize much because it seems like it's very easy. For some people, Earth is so-so, directions is very good. For some people, Earth is also easy, directions are also easy. We want to be such people for whom Earth and directions both make easy sense. All right. Now, Earth, although taught in general navigation, okay, Earth is taught separately and directions are taught separately. but in Earth, directions are also included. So why not combine everything and study side by side and try to relate? Now, we need to first understand the need of why are we learning what we are learning. Okay, so let's say that Shubhankar has started. Shubhankar has started. Now, Shubhankar should know that why am I doing navigation? First thing. Now, most of you all already know I'm doing navigation because I want to safely carry my payload from point A to point B. And navigation is an art and science of helping me reach from point A to point B safely with my payload. Something like that. So, how do you ensure you reach safely from point A to point B? Okay, you should know how to fly the plane. Is navigation teaching you how to fly the plane? No. Then what's the purpose? Then what's the meaning of navigation? Okay, so navigation tells you no matter what kind of airplane you are going to be in, the strategy for navigation, the elements of navigation are going to be common, which is being taught to you in CPL studies. Oh, I see. Okay, that's how it is. Of course, that's how it is. They're not going to teach you how to fly a plane. That you'll learn when you do flight training and type rating. But what you're learning here is universally applicable in every cockpit. Be it a small aircraft, be it a mid-range aircraft, be it a heavy aircraft or a super heavy aircraft. You understand, students? So you understand the concept, the logic, it becomes much more easier. Especially Manan Nandini, when you had started, probably you would have thought, okay, navigation, I've heard so much about navigation. But now, as you see, you have almost completed everything and you almost have understood everything. When you understand things, you tend to, have a power over them, over those topics. So make sure that's your strength. Understand. As long as you don't understand, keep asking. Sir, I'm not understanding. Sir, I'm not understanding. Sir, I'm not understanding. Okay. Sometimes I'll, get a little what do we say? Strict with you to increase your focus. You focus on learning. That's it. So we need focus, of course. We need understanding, of course. But why I'm preaching so much before starting? I'm preaching because I want you all to know that you have to ask, you have to talk, you have to give answers, and you have to have discussions live in class. Okay. Make sure you make the most of the live sessions that you're getting. Discussions are more important. Manan, Nandini, Rishi, Jyotsna. For you, for the topic studied and covered, discussions are very important. Okay. Gulshan, Shubhankar, Suchita, Yukti. For you, questions are more important. Why? Why? Till the time you know everything, you should be thinking why and how and what. Those are the questions. And Manan, Nandini, Rishi, Josna, you all also on the same lines, but more than questions, it should be discussions that, okay, what if you give yourself certain situations and think about it? Anyway, these little points, I think it's good that I show you all a few things before we get started when we restart lectures or start lectures. Anyway, I'll keep reminding you all about these things little by little. Before I get started, any questions for me? Let me know. Think. Anyone has any question? A lot of our class is missing. Monday blues, I guess, huh? No questions? If no questions, then say no questions. That is important in aviation. At least reply. See, this is what I don't like. Nobody's given no acknowledgement to this question of mine.
No question, sir.
I got only 2 acknowledgements. One in chat,
No
one
question,
in
sir.
verbal.
No question, sir.
No question, sir.
No questions, sir.
No question, sir.
Sushita? How about you, Suchita? Any questions? Suchita Mishra, are you there? See, the one more importance of acknowledgement is to ensure that you are also there in class, because sometimes you can have a disconnection, your system can get frozen. Sometimes the students fall asleep also, and the videos are off, so I don't know. How will I know if a student is learning or not, if the students are not responding, not acknowledging? So it's your duty to keep acknowledging and keep affirming without me having to ask again, students. See, I only ask for a few things from you. Please make sure you give them to me so that you're not in the blind. Sushita, please respond. You're on mute. Are you there? One second, okay? One more important element that involves in your navigation and art of flying, although it's not rightly directly there, but it's your sleep cycle, everyday sleep cycle. Okay. uh if you will not get enough sleep, students, your mind will not be able to function. So as a pilot, it'll be very important. But why I'm saying this, because sometimes when we have early sessions, especially on a Monday, and we know how weekends are, they're very unpredictable. You could have a lot of meetings, you could have a lot of work, or maybe some personal commitments. All right. So if you have not slept enough, you'll not be able to perform. So make sure that you all, even as students, have a good sleeping cycle and good sleeping schedule. If you don't have it, then make it simple. No matter when you sleep, what time you sleep, 6 to 8 hours minimum to start with. These days, we youngsters, what do? We get by with 3-4 hours also, 5 hours also. But in the long run, it's not healthy for us, for our profession. All right. I'm saying this because I've had very less sleep since past few days. And sometimes when I'm working, I feel that I'm feeling sleepy. When that happens, it means the body finally needs some sleep. You have exhausted all your energy. It's like that. Anyway, little tricks will help you in the long run. Make sure you make the most of it. Let's get started now. I hope everyone can see the whiteboard. Anyone will have, if you all have any problem, please feel free to ask. Suchita, try to say something verbally possible. Is your phone working fine now?
Yes, sir. I just connected to Bluetooth and that's the reason.
Okay, good. Thank you.
Yes, sir.
Okay. All right. So navigation again. First, we see navigation has 3 parts, right? Manan, what are the 3 parts?
General nav, radio nav, and instruments.
Yeah. General nav. Very good, Manan. Thank you. Radio nav and instruments. Okay. Now, Nandini, what do you think is going to be the weightage? Okay. General nav, radio nav, and instruments. Like, what do you think? Out of 100, how much goes to general, how much goes to radio, how much goes to instruments?
So I'm not sure about that, but I think more weightage will be to instruments and then to general nav and then radio navigation.
Instruments, general nav, and radio nav. Okay, very nice. See, students, talking about these different aspects of your navigation syllabus, what is general navigation? What is radio navigation? What is instrument or instrument navigation? Now, instruments, okay, can be related to your radio navs or can be related to your general nav instruments. We don't have many general nav based instruments, but we do have many instruments that we use during general navigation. So what is this general navigation? Are pilots changing from one form of navigation to another? No. Then why are we learning it in 3 different ways? Or why do we call it general? Why do we call it radio? Why do we call it instruments? Okay, so you have to really understand what happens is when we talk about general navigation. Okay, firstly and foremost, it talks about VFR flights. Okay, VFR flights. Radio nav and instruments mostly will deal with IFR flights. Okay, directly. Now, but when we say general nav, then the general nav skills are of utmost importance to a VFR pilot. Now, who is a VFR pilot? You as a flight student and your instructor, you both would be initially VFR pilots because you would be only allowed to carry those flights. After some time, you will be sent for IFR flights. And remember, when aviation was started, the first type of flights were VFR flights. Just because VFR flights were not safe and not feasible, that we invented navigation modes and mediums, instruments and radio nav systems to help us work out the problems with VFR flights. So when I say general navigation, why VFR flights? Because with VFR flights, what is VFR? Visual flight rules. Visual flight rules. Okay. Not just visual flight rules, you actually navigate. Okay. You actually navigate looking at physical locations on ground below you when you're flying at a low altitude, maybe 4,000 feet, 5,000 feet, 6, 7, 8, 9, 10,000, 11,000 feet or so. The ground is visible and ground is prominently visible even from 30, 35,000 feet if you don't have clouds or if you have the sky as clear sky. So visual references are easy, but for planes flying at super high speeds, at higher altitudes, visual navigation is not feasible. But for smaller planes, visual navigation, visual flight rules, and it is feasible. So you need to understand that half of the calculations that you would be doing, although applicable in both sorts of flights, VFR and IFR, the reality of you having to do it in the cockpit would be more in VFR flights and less in your IFR flights. Okay, so that's why it's very important, because first and foremost, you have to be a VFR pilot. Only then you will be making a good IFR pilot. If you only try to be an IFR pilot and if you're not good at general navigation, then you are just a half pilot. You're not a pilot who could work in emergencies because you don't know how to do visual flights. You don't know how to navigate without radio and instruments. So that's why we think that general nav, we could say, should be 50%. And these two should be 50% like this, ideally. Now, what Nandini said, she is correct. But anytime you can assume this also, or you can assume 35, 35, and 30 also. Or maybe you can assume, like Nandini said, 40 and maybe 30, not 30, maybe 20, yeah, 30 and maybe 30, like this. So sometimes some questions will be more from general nav and equally from radio instruments. Sometimes some questions will be more from radio and instruments and less from general nav. So there's no fixed way of saying which will come more, but I could say that, okay, everything is just one thing. Because when you fly an airline for which you are preparing right now, that is a modern jetliner, maybe an Airbus 321, 737, 787s, or other aircrafts, or maybe new aircrafts by the time you get selected for an airline, then you just have to understand, students, that, you know, these concepts are universally applicable no matter what kind of aircraft. Okay. And the aircraft that you'll be flying, a jetliner, is a combination of everything. Although you won't be required to make many calculations, even in such sophisticated aircrafts, you should know how to make those calculations. That's what you learn in general navigation, how to make those calculations. So what are those calculations? So those are the different topics in general navigation, nothing else. So what are those calculations like? What will be it? Total distance to be flown, total distance to fly from A to B, So this A to B, A to B, A to B, what is this? You see a lot of this in general navigation. From A to B means A means departure, B means destination, like this. So total distance, of course, you will know total distance, okay? It will be with you. Let's say you're flying from Delhi to Kolkata, okay? So you will know what ATS route to fly. You will know what altitude to fly. How? Because you'll be given a flight plan. So you see flight plan, distances, speeds, fuel, everything that goes into preparation to make a flight ready to fly, that also is a part of general navigation. Weight and balance. Is your aircraft overweight? Is your aircraft underweight? Emergency calculations, pre-calculations for emergencies related to fuel and emergencies related to time. Pre-calculations focusing what to do in case of fuel emergency or time-based emergency. Should we come back? Should we proceed to the destination? I'm referring to PNR and CP. How much fuel to carry? I want to make sure I don't carry excess fuel. If I carry excess fuel than I need, my aircraft will be heavier than what it needs to be, and I'll not make profits as an airline. And if I'm not making profits, how will I give jobs to people? So I need to make profit so that I can create more jobs, more pilots. So I have to make sure my weight and balance, my fuel consumption, everything. So students, the general navigation is very important. It's a very creative field. And if you master general navigation, you will be a master of navigation, irrespective of anything. Even a jetliner, if you don't really understand all of the complicated instruments, if you do general navigation, you'll be able to notice those 2-3 instruments which will be able to increase your chances of safely executing a situation or an emergency based intention of yours. So I want your attention first to be on general navigation. Manan, Nandini, Jyotsna, Rishi, how much ever of general navigation we have done, we have to revise that nicely and steadily. Solve questions, solve difficult questions, discuss possibilities. What if, what if, what if, what if this, what if that, and so on. So total distance to fly, required fuel, or I could say required flight fuel. Flight fuel is the fuel required for that particular flight. Then this is very important. Point of no return, critical point. These over here, right? Pre-flight. VFR flights pre-flight. Half of your general navigation is all about pre-flights. What to do pre-flight. So that again becomes a universal agenda. So you should see that somewhere around, I think general navigation would have at least 30 to 40 questions in the examination. Okay. 30 to 40 out of 70. Imagine if you master general navigation, you're very close to getting 70 on your own just with general navigation. If you master general navigation, easy to crack 40, 45, easily 40 with general navigation only. And it's easy because it's fresh, it's new. So one thing, second, third, critical point. What is point of no return and critical point? You will see all these are pre-flight things. Flight plans. Many students who have done RT, you all already know what are flight plans. A flight plan is basically the blueprint of your flight that you're going to pursue. It has a lot of important elements which you have to study for your navigation exams. It's like a form, you know. Great circle, rum line, convergency. These concepts are related to Earth. Why do you need this? You need it to calculate great circle. Why great circle? Because if you want to fly from A to B, then you will follow a track that is a short arc of a great circle. Nandini, if you understand, then explain this point.
It's like great circle is a circle on the surface of the earth, which has the same radius as that of the Earth and the same center. So there's the shortest arc on the great circle will be the shortest distance between the 2 points. Pilots would prefer that point to fly.
Very nice. Pilots, aviators, dispatchers, everyone would prefer flying from A to B through a great circle track. Radio waves, when they travel in the atmosphere, they also follow great circle tracks because it's the shortest path. Most of our ATS routes you will see are aligned with the great circle tracks. So sometimes for general navigation pilots who don't have routes, or maybe if you just have an airplane, how will you make sure that you make your own route, or you find yourself or give yourself directions? Then you first solve great circle, find the great circle directions or tracks. And once you find that track, just fly that track. How do you fly that track? By reading the instruments carefully, by checking what you had planned to fly. Are you flying that or not? Considering what you had assumed about the weather still stays. It is like that. So Earth is about that. Then in general navigation, we have magnetism and compass. That is a magnetic compass. So in magnetism, we have Earth magnetism, aircraft magnetism, hard iron magnetism, soft iron magnetism, and so on. Why magnetism in general navigation? Because Earth has a magnetic field. Earth behaves as if there is a small bar magnet going through the center. Earth is magnetic. Radio waves are electromagnetic. An alternating AC current has a magnetic field oscillating. Magnets are everywhere. Your doorbell works on a magnet. Transformers, induction coils, your wireless chargers, your induction cookers, everything works on these concepts, magnetic and electromagnetic. So you learn about that, you learn about Earth's magnetic field. So students, Manan, Nandini, Manan, tell me about Earth's magnetic field. Horizontal component, vertical component. I'll help you get started. See, I think now you'll recollect. Tell me.
Yeah, so the horizontal component is maximum at the equator, and the vertical component is maximum at the poles. So the compass reading is more accurate at the equator and less accurate at the poles. So generally we fly nearer to equator, like latitudes from 0 to 60° north-south, generally.
Very good. Very well said. Very clean answer. Nandini, one key element Manan has missed saying. I won't say missed, he just didn't say it. Can you think about it? It's related to a force of the magnetic compass. What force is it? And it's related to what? Horizontal component or magnetic component? Come on, Nandini.
Sir, is it like H and V force?
H and V are horizontal and vertical. We know, I think it's Zulu. No, yeah, not V. What is vertical component? Z. I think Z. And T is total component. But no, what I'm talking about is directive force. Does it click, Manan? Manan, does it click? Directive force?
Affirms.
Nandini, what gives the magnetism its directive force? What is a directive force? A magnetic compass, okay, it points to the north. Okay, how accurately does it point to the north? That is its directive force. What is this directive force of a magnetic compass based upon? It's based upon the Earth's horizontal magnetic component. Manan, can you relate with it? Nandini, can you relate with it? Key points, very important key point.
Form, sir.
Manan, the answer that you gave is because of this. Why do we get accurate reading on the equator? Why do we get horizontal maximum on the equator? And why do we get accurate readings on the equator? Because horizontal component of the Earth's magnetic field is the directive force in a compass. So wherever the directive force is maximum, my compass reading will be accurate. So where is my directive force maximum? My magnetic directive force is max at equator. So my compass is accurate at equator. Like that. That is the directive force. Got it, everyone? Easy points. I'm just discussing. It's not like we're just talking about general navigation right now. Achal, welcome to the class. Good morning. How do you read? Very nice, Achal. Good morning. Welcome to the class. So, Achal, we are doing fundamentals and we are just revising, discussing everything. So, you've not missed much, though. We're just talking about general aspects and fundamentals. So, see, whenever you get time, just go through it. You've not missed much, but it'll just increase your overall understanding of navigation again. Okay, so make sure you do that and continue from what I'm doing right now. So in general nav, I'll have mostly applicable for VFF flights. I'm not saying not applicable for IFF flights, but for VFF flights, it is the only way you will navigate. You don't have any other way to navigate. Okay. I have this, I'm not sure if we'll be able to keep those videos. I think maybe yes, because many gamers do that, right? I'm not talking about that, but I have certain good graphics to show you through a simulator program. So I'm thinking that in class I can share that screen and I can show you these things. The latest version of the FSX Microsoft Simulator has really good sky patterns printed, which can really increase a beginner's understanding of how things are. So that would be nice for you to see. Actually, if you would have more time, then I would also suggest that along with your ground training that you're doing, as a hobby only, you could try to apply these by using whatever computers you have. On the same, just basic trial version of the sim can also work. You don't have to buy, but you could also always try, maybe get a joystick like this or something, and maybe just do and apply. You will see the language in flight training and the language in ground training sometime might not relate because they might be from the US or the UK and we are here, but you'll see the application is the same. So that really makes you much more confident and more knowledgeable in a short period of time. But you don't need to rush. You can take your time before you do that, but it's just something that you could do extra. Anybody who needs help getting started, if you don't know how to go about it, you can just let me know and you can give it a try. If the new version doesn't work for you, if your system is old, the old version of FSX will easily work. It is a very small file. All right. Anyway, I'll show you all a lot of the graphics. So we talk about general navigation because it's the only way of navigating in VFR flights, and that's why it's important. General navigation will carry a weightage of 40 to 50. On any day, ideally, it should carry that much, but at least 30-35 would be asked. So first primary focus would be general navigation. Okay, because that is easy and that is something that requires a lot of creativity. You cannot verbatim learn everything in general navigation. You can verbatim learn formulas, rules, thumb rules, okay, and principles, definitions, of course, yes, like directive force, horizontal component, earth magnetic pole, earth axis, great circle, rhumb line, they all have definitions that you have to learn verbatim. But what is tricky in general navigation is numericals. So 80% of your numericals, let's reduce it to 70. 70% of your numericals, they will come from general navigation. And now when you talk about the weightage between numericals and theoretical questions in navigation, then 50 numericals, 50 theory questions. Now I'm saying all numericals come from general navigation, 70% of general navigation. So out of those 50, 35 would be from general navigation. If not 50, if you're getting only 40 numericals and 60 theory questions, then out of those 40 numericals, about 30 numericals would be from general navigation. So now you know the importance of general navigation. You master general navigation, and 50% you can say your navigation is done. So then you only need 20% to pass between radio nav and instrumentation. So initially, if you work it out this way, then at least you can guarantee that you'll pass with good amount of knowledge, if not all knowledge, just in case if you think you are underprepared, still you have to give the exam. So that works. But that being said, first master general navigation, then equally master instrument and radio to get 100%. Why just aim for 70 when you have a scope to grow till 100? It's like that. Got it, students? Kindly acknowledge. What am I saying? Making sense? Yes, no, maybe? Quickly.
Yes, sir.
Yes, sir.
Yes, sir.
How about you, Gulshan?
Yes, sir.
Then we have students, don't make me tell, please make it a habit that you all will acknowledge. Everyone has to acknowledge. It's very important. See, I'm giving you the liberty to not turn on your videos. Okay? But I need your acknowledgement so that I know at least you are there. Okay? If I'm teaching you all, if you all are there in live class, and if say Rishi is asleep and he doesn't follow, then it's a loss. It's like that. And you never know, some people might be eating and mothers, fathers, brothers, sisters, cousins, friends would be there around talking and disturbing you again and again. It's not your fault. It happens when you're learning in a class online session. It's okay when you're at home. But if I can see that happening, then I will repeat automatically things so that you don't forget. If I see that happening, I'll just stay quiet and let that disturbance go. I'm like that. Okay. But when the videos are off, I'm like that because I don't want my students to miss anything. See, I'm setting all expectations before we get started, because this time onwards, your sessions are going like, you will see what I'm talking about. You'll be learning a lot in a short period of time. So if you miss out, if I don't know, then although your syllabus would be over, but you'll not get the marks. And then you'll be like, sir, I don't know, maybe just I'm not a good student, that I didn't work hard and all. No, it's not about that. You just missed a few things because of distractions. Don't worry about it. It's just that much. So you should be aware if you're distracted. See, your videos are off. I don't know. Like I was calling Suchita, she took some time to respond. I don't know if she was distracted or disconnection or what. Later on, she said, sir, nothing. I was just listening to you, but my mic was not working. Like that. So I tried to arrange for a different mic and it's working for me now. Okay, good. But the concern is very important. So make sure you all acknowledge. Okay. I'm just saying it. I say it again and again. It's a first class. So I'm saying it. Charts. Why charts? Because the charts are 2D representation of 3D Earth. We cannot carry a 3D model, a globe in the cockpit to navigate. It is not enough. It will not be accurate. In order to get the accuracy, we get small charts with high accuracy, and we get a lot of charts. This huge is the bundle of Jefferson chart book 1 and book 2. This thick one booklet, this thick another booklet, small charts, small charts. There are big charts also during flight planning. And then in the cockpit, small charts, they're like pieces of jigsaw puzzle. If you join them all, you'll be able to see a bigger chart. Not completely joining, but yeah, you can make sense. So sorry. So why do you do charts? Because it's a representation of the Earth. So why do you study Earth? Why will I not study Earth as a pilot? Because I have to take off from the Earth and I have to land back at the Earth. Okay, that's why you need to learn Earth. Of course, that's why I need to learn Earth. So would you be learning about the moon if you would be pilot on the moon? Of course, I'd be learning about the moon. Because every planet has a very different characteristic. So you'll be learning a lot about Earth, plus you'll also be learning about Earth. Related to Earth would be solar system, seasons, time, twilights. So we saw Earth also has great circle, rum line, convergency that talks about the form of the Earth and the system of numbering every physical location on the Earth. Every physical location can be pinpointed on the Earth with the system that we have today. So there are three things that you'll be learning in Earth. Firstly, something to do with the Earth's root. I think not just three, four. You'll be doing a lot of things on Earth. So how four? I'll tell you. Earth, first thing you'd learn would be directions. So directions are completely based upon Earth only. Then the second thing about Earth you will learn would be graticule. Graticule, nothing but it is just latitudes, longitudes, meridians, great circle, convergency, rum line. So first latitude, longitude. This latitude, longitude can help you determine any point on the Earth. Wherever you are, Yukti, Rishi, Achal, Gulshan, wherever you are, your GPS in your mobile phone can give me your exact latitude and longitude in decimals. So that is the whole system. Why do I need this? If you're wondering, let's say that I want to fly to Gulshan right now. So what do? I find out my latitude, longitude. So you learn what are latitude, longitudes, and others. We have to revise this, of course. So what are latitude, longitudes? I'll discuss my latitude. I'll discover. I'll find it out. Let's say my latitude, longitude is something. Let me check with my GPS if I can find it. So I'll find my latitude, longitude. I'm point A. Then Gulshan is point B. So I'll need Gulshan's latitude and longitude. Okay. Once I find Gulshan's latitude and longitude, I'll need a formula to find my great circle track between me and there. The formula will require the use of latitude and longitudes. It is like that. So how do you create your ATC tracks? How do you choose your great circles? Through certain formulas. So first you need directions. You need directions for flying on right path or track. Graticule to locate every position. Then the third thing in Earth, the third thing in the Earth would be GC, rum line, convergency. What are these things? Great circle, rum line, convergency. They help find right direction and path to find. So this direction for flying on the right path, we attain these directions from the calculation of great circle, rum line, convergency. Those calculations can be done if we know the graticule, longitude and latitude and related parameters. Do you understand how it is interrelated, students? Even if you miss one point, let's say you are weak in directions or you're weak in graticule based points or you're weak in great circle based points, then your knowledge, somewhere you'll make mistakes. Chances are, And if you make mistakes, then you might lose 1 mark or 2. And the importance of a mark or 2, students remember, 70, great. 69, give the exam again. That's the importance of 1 mark. Ask those students who get 68 and 69. Imagine how they must feel, like one mistake I made, one mistake. And why am I talking about mistake? I'm not worried about you giving answers wrongly to questions that you have not studied. No, I'm not worried about that. If you don't know, how will you give the right answer, right? But what about the questions that you have studied? What if you give wrong answers to them also? Every student I've seen in my experience, somewhere or the other, can make a mistake on the right question which he or she has studied, up to 10 to 15 questions for every exam. 10 to 15 would be lost by you, by yourself. You won't even know. Minimum, I'm saying. You will think you have done the right thing. So be very careful, okay? And this is not all, no? I have one more element about Earth, which is magnetism. Now, magnetism helps me with directions or navigation. Magnetic compass, like that. So I'll say magnetism, compass based navigation. Simple. It helps with compass based navigation. Compass based navigation is independent navigation. You don't need anything for that. Okay. Any questions so far? Is it making sense? See, student, this is what makes you smart. This is what makes your job easy. This is what makes your revisions easy. This is what makes your first time learning easy. All right. This understanding. Once you understand it, afterwards, learning concepts is just a piece of cake. It's very easy. I think navigation is very easy. It's as easy as other subjects. I personally find navigation better than regulations. Not that I don't enjoy regulations. I like everything because it's a gold mine of knowledge, regulations. If you're good with knowledge of regulations, then actually you'll be good in the business industry. That is your job as a pilot. Equally applies to MET and NAV also. But for MET, we can depend mainly upon our flight dispatches. So I think, and regs, we can say that probably your managers or your duty in charges or your group leaders, they would be, taking care of all your requirements, legal requirements related to regulation. So what will be in your hand in the end? It will be the art of navigation, your RT communication, and your understanding of your aircraft, that is technical. So these three elements you would always need to be self-dependent upon. Regs and MET be best, but for that you have support. I'm just saying practically how it is. It doesn't mean your ground studies you will not focus on regs and MET. Otherwise, you'll not be eligible to apply for your CPL license, okay? And understand, when you are a VFR pilot, which is the basic requirement for you to be a pilot. Like say, if I want to be a heart specialist or maybe a kidney specialist or any specialist of the body as a doctor, first I need to do an MBBS, right? A basic doctor. Some people can be a physician just based on MBBS, but they cannot be surgeons, cannot be specialists, right? In order to do the specialization, they have to do further MDs and this and that, so many other variants. Exactly like that is how your aviation studies are. Your CPL is just like basic MBBS. Okay. But then you will be able to know everything about the body, like any aircraft. But can you deal with the heart? No, you have to master the heart. Can you fly an Airbus 320? No, you have to master the 320. It's like that. Got it, students? So all that you're learning in CPL is MBBS. Do you understand? It's like that. I'll keep giving you all examples. If your mindset is set, you all will clear in your first attempts. It happens. If this many students, all navigation 100% first attempt results. RT, it's reduced a little bit because some students are not properly prepared. It's okay. RT, it's okay. RT, even still, we are getting 80% first time results. It's very good, Earlier, I had a track of 100, but it's okay. I mean, I want to go for numbers. Otherwise, I'll just choose those people who I know will clear. So, anyway, what I'm trying to say is don't take it lightly, students, okay? Plus, when I talk about Earth, I told you that there may be more points also. There's one more point on Earth, that is the representation of the Earth on a 2D paper for me to carry it for navigation. Projections. So projections means how a 3D model of Earth is exactly or accurately represented on a 2D chart. How? How is it done? Sorry. How is it done? This is projection. So there are three types of projections. Sorry, students. There are three types of projections. One, we keep the chart or the paper like this. We make a small model of the bigger real Earth. We call this model reduced Earth. In this model, we place a small light source inside the model, inside the Earth. We turn on the light, and then there are lines and everything, graticules. Basically, meridians are lines from North Pole to South Pole. Latitudes are lines which are like this. So when the light comes out from the reduced Earth, a paper is kept and the line is traced on the paper because the lines, because of the light, are reflected on the paper. On that paper, whatever lines you get, you print it out, and that becomes a projection. Okay. And that chart you follow. Now, that chart, depending upon what kind of projection you have had, will have certain benefits and certain disadvantages. So that is what you will be studying in projections. So what type of projections we have? We have conical, we have cylindrical, and we have polar stereographic. Sorry, I'll just talking about MBBS. I've started writing like an MBBS, right? Unable to decipher what I've written. Sorry for that. Conical and then cylindrical. You know, in my school also, although my English was not good, my English was not good, but I was amongst the top students to do anything related to English. Imagine the level of our school's training. And we only had one good teacher for English, you know. She was really good, but she also had limited knowledge. Now that we have learned more, we realize that, okay, half of the things learned was wrong. I'm saying this because these days I'm unable to, you know, I'm facing challenges with spellings, you know, few spellings. So just sharing my thoughts, you know, like when you lose practice, because when you're chatting, even if you write wrong spelling, it autocorrects. When you're emailing, it autocorrects. When you're doing something digital, making notes, it autocorrects. So you don't really care, you know, you just type fast, 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 you know, even if there's any mistake later on, you can autocorrect. So I think that's the reason why, you know, our tendency to make some spellings over can go, you know. So be very careful, students. Yeah. And polar stereographic. Okay. Is anyone wondering, sir, stereographic, does it give sound and visuals? Is it a music video? Is it an iPad projection? Anyone thinking like that? Stereographic. Anyone like that joke? Manan? Gulshan Rishi? Stereographic. Stereo is sound, graphic, visuals, no? iPad-based charts. Actually, iPads are used in cockpits for GPS, but as a secondary mode of secondary reference for navigation. No, it's not. It's not what I'm saying. But other students, no reactions. Students, you know, right? Middle of the class, towards the end of the class, I'll try to crack a few jokes. Either make fun for everyone or either make fun of myself. But at least you'll laugh, right? Finally, it's difficult to get reactions from Achal and Jyotsna. And Nandini also, I guess. Yukti has given. I think I'll have to come up with better sense of humor for y'all. I'm just kidding. Students, it's okay. Enjoy. All right. It's just the first lecture. I have no expectations from anyone. So we are taking it easy. As we go ahead, if you all don't perform well, then you'll see I'm not smiling. I'm not cracking jokes, but I'm shouting. So please make sure you follow and focus. Okay. So projections is this, you learn about projections, then different type of projections are used in different areas. Those will have different pros and different cons. So please make sure that you cover that also. Then, so Earth is multifold. Are you getting it? Earth is multifold. Earth we have to master. So 1/3 of your navigation is all about Earth. Easy, right? Then let's quickly do it. The most important general navigation aspect is DR navigation or dead reckoning. DR. This is your VFR completely. Your DR is very important. Okay. DR you do with the help of visual references, or you do with the help of speed, distance, time relationship, the formula between speed, distance, time, or visual references. Generally, dead reckoning is all about that. Okay. 11 will do in-flight navigation. Now, in-flight navigation is mainly dependent upon 1/60 rule. 1/60 rule will give you track error angles, closing angles, total correction angles, track made goods, required track. In-flight navigation will also talk about drift, allowed drift, correction for drift. Okay, before Shubhankar goes to his class, students, I just want to give you all instructions. So we're just getting started. This week, we have back-to-back lectures, Monday and Tuesday. Okay. If any special lectures need, I'll announce privately, Manan, Nandini, others. Okay. For now, what we are trying to do is, cover in depth a lot of points on the same day for the same topic to manage more quality. That being said, morning and evening session, sorry, morning and afternoon, like 9 to whatever the schedule is to, yes, it's just one lecture divided in two parts. So if you're attending morning, you also attend evening also, because it's continuing. Wherever we stop at 11 o'clock, we'll resume from 12 o'clock from there only. It's like that. All right. Because we need more time to do more things thoroughly. Okay. Second thing, Shubhankar, today, so students, today we are not going to do the 12 p.m. lecture for now. All right. So today you don't have to join. Tomorrow we'll have that. So today is just, getting an idea about what we are supposed to do in these sessions for navigation. All right. And understanding everything. So always, when you get started, I don't put much of weight on y'all. So Shubhankar, this will be only it. I think we'll only have to see the last 30 minutes or whatever you'll be missing. So don't worry about it. All right. And actually, you just have to see initial few part. You have also not missed much. But make sure you do it, okay? Because I really need you all to have this understanding that I'm sharing with you all about the subject. So about drift, let's come back. So in-flight navigation, 1/60 rule, then drift calculations, allowed drift, correction drift. What kind of drifts do we have? We have port drifts and we have starboard drifts. So what is to port drift and starboard drift? If this is my airplane, my left side is port, my right side is starboard. Okay. So this is port, this is starboard. What is port drift and starboard drift? So let's say this is your required track. Your required track is 005 degrees. It's a direction. You learn everything. What are directions, how they are found and everything. Okay, let's say this is your required track. You have to follow this. So the aircraft is here, like this. Okay. Everyone understands this green aircraft? This is the nose. Okay. So this aircraft is required to fly. Now what happens? Suddenly you get a gust of wind from this side. Okay, wind vector. you get a wind vector. Let's say you get, what is this side? This is 0, 9 at 0. Wind is coming from 0, 9 at 0. Let's say at 20 knots. So wind speed and wind direction. Wind vector will always be in two values: wind speed, wind direction, or wind direction, wind speed. So wind's coming from 0, 9 at 0 at 20 knots. This is how you say. So right now, this aircraft, let's say this aircraft is iFly 101, that is iFly 101. Then iFly 101 is flying on a required track of 005. Nice, the pilot is easily flying. Let's say this route is Alpha 474. Okay, and the pilot is going easily, nicely. Suddenly, the pilot experiences wind from 09 at 0 at 20 knots. So what happens? The aircraft. Now, note in this situation, the pilot didn't anticipate any wind. The pilot was taking along with the flight, thinking, calculating in his or her flight plan that this is a zero wind or nil wind situation. Nil wind situation, zero wind situation. That was the plan in this case. In such a case, the pilot had to fly straight. All of a sudden, the pilot got a wind. This was unpredicted wind. Got it? Unpredicted wind. So now this wind, what will the wind do? The wind is coming from starboard, so it will push my aircraft to the port side. And instead of tracking what I need to track, my required track would become like this. Instead of following the blue line, my aircraft will continue to follow the green line, because my aircraft is being pushed on the other side by the wind coming from this side. So my aircraft will not know that its nose orientation has changed, and the aircraft nose will remain in the same direction, 005. But the path that the aircraft is flying will change like this. This will happen. Now what happens? You have deviated from your track unknowingly. Your nose is still pointing in the same direction. The direction in which your nose points is called the heading, while the path that the CG of the aircraft traces is called the flight path or the track. Okay? So, heading, track, or flight path. What is heading? Heading is direction in which, students, make sure whatever you're learning now. Achal, you were late, so I forgot to give. You didn't hear this instruction. Whatever you're learning, if you have done this before, and if you're doing it now, then it means that should be your final preparation on these topics. Okay. So direction in which longitudinal axis of aircraft points, in bracket, or the nose of the aircraft. The longitudinal axis is an axis, imaginary line, passing from the nose of the aircraft to the tail of the aircraft. A straight line like this, passing imaginary, which is very important element in an aircraft design, manufacture, aerodynamics, stability, and everything else. What is track or flight path? It is the path traced by the CG of the aircraft. What is CG? CG is center of gravity. So now you know the aircraft can point in the direction of its flight path when there is no wind. But when there is wind, the aircraft will not point in the direction of the flight path. The aircraft will fly differently if it is pointing in the same direction. So in order to fly in the same direction required 005, I will need to point in a different direction so that I don't get deviated on the green track. So this, if my flight dispatchers, if my weather reports, if my weather forecast, if they can help me, if these things can help me forecast a wind before flight, which actually is not a part in your navigation exam, which ideally should have been. Such exercises are there in abroad, but not in India, to file a real flight plan and all. But if, let's say, you would know how to do it, then you would already anticipate the wind, you will already anticipate the drift, and you'll already have made the correction to your heading to stay on track. Now, those drifts are the real drifts discussed in your navigation exams, theories, textbooks. So what I've shown you right now is not actually drift with respect to the texts and the theories that you're going to learn. Although this is how drift happens, but in aviation terms, we don't call this a drift. We call the drift when we had anticipated or predicted the wind. Okay. So if I give you a predicted wind, same situation, let's say this wind was predicted wind, same, 090 at 20 knots. So if my pilot had predicted at this position that he or she is going to get this wind, so now my pilot knows that this wind was shifting me on the left side, let's say by some value, let's say 5 degrees. If it was pre-calculated, which will be, there are formulas. There is a computer, CX3. Okay. If you know a few elements, then you can find the other elements. So if this wind was anticipated correctly, then my pilot would have known what to do to allow for the drift. That allowed drift is the drift discussed everywhere in your theory books. Now, this is one confusion which prevents good students also from clearing in their first attempts in navigation, because they tend to do the opposite, which is what I've shown you right now. They tend to do this, which is the logical reasoning. But the drift discussed in our books and theories is the allowable drift. So you need to know how that looks like. So when I show you the real effect, what do you think happens? We think that the heading is on the left of the required track because the aircraft has shifted to the left of the required track, but that becomes wrong because this is not that drift. So this becomes a track error angle. There is an error in the track, and we call the new track, the green direction, of course, 5 degrees. So it will be 0, 0, 0. That green direction would be track made good. So that becomes track made good. The RT becomes required track. So if I have to show this to you in a proper diagram, what happens is, see, these are the directions: 0, 0, 0, 0, 9, 0, 180, 270. Some students, if you're thinking, why does sir show the same thing directions almost in every nav class? Students, your navigation secret to solve is this plus symbol, cardinal points. Real life commanders, 50-year-old commanders, 60-year-old commanders, they still use this technique, reading their instruments. Okay, so don't take it lightly. The reason I'm saying it again and again, so that you remember that whenever you're dealing with directions, general navigation, you can always refer to this cardinal point system also. So this 0, 0, 0 means this is 0, 0, 0. Okay, required track 0, 0, 0. What is no, not required track. This is the cardinal point, north, true north or magnetic north, whatever. My required track is 0, 0, 5. So let's say from center, if I want to make 0, 0, 5, then 0, 0, 5 will go like this. 0, 0, 5. Now I told you all the deviation caused by the wind was 5 degrees. So this is difference is 5 degrees. So how much is the value? 0, 0, 0, 5 degrees. So reference starts from 0, 0, 0, 5. So the difference is 5 degrees. If you can calculate that difference, that the wind is going to push you 5 degrees to the right. So what happens? This becomes your required track and this becomes your track made good, like this. So at the moment, if If the wind was not anticipated, then I see that my aircraft is looking like this. Here also, and the more I go away, the more the aircraft will be parallel to 005 because it's maintaining 005 heading, but you see the flight path, the path traced by the CG of the aircraft in air is different. So this becomes TMG, although you're heading. So the pilot will actually not know that you have been deviated from the track unless you keep checking every 5-10 minutes for any visual references or radio-based bearings, whatever works. Everyone getting it? So this error that I have in my required track and track made good is actually called your track error angle. Correct, students? Students who have done general navigation already, this is for you to revise thoroughly, nicely. First timers, good introduction, little bit you learn. Make sure, try to get as much as you can. Rest, keep it in your parking lot, discuss doubts. All these topics will be taught to you independently. Also, of course, everything in detail. This is just a generic overview. Okay. So this is what is happening in there, over there. Okay, this is what is happening, but I don't want this to happen. What do I want? So here what happens? We think that the aircraft heading is on the left of the required track. Why? Because the wind is coming from the starboard. So we think that in port drift, we think that heading is left of required track or port of required track. We think like this, and this is what confuses you as a student. This is wrong. Wrong. No, this is wrong. Then what is the right version? This is the right version. So if I can calculate the anticipated wind, so this is my required track. Sorry. So this is my required track 005. Let's stretch it a little more. Okay. So this is my required track 005. Required track. I want to fly in this direction. Now my anticipated wind was from 090 at 20 knots. Okay. Now my aircraft is here. My aircraft is here. Earlier my aircraft was flying straight, nil wind situation. But now my aircraft knows my aircraft is going to be pushed on that side by 5 degrees. So my pilot will correct before it gets deviated. A good pilot will correct before it's deviated. So what will be the correction? It will be opposite to the effect of the drift. So the drift was going to the port. So now my correction will be to the starboard side, opposite side. Correction to what? Only your heading. If you change your heading, you can maintain your track. So here, what will my pilot do? My pilot would my pilot would make sure that the value, how do I obtain that value? Through the CX3 computer that you are allowed to carry in exams also, in cockpits also. Okay. This is the required track. 5 degree, I'm going to be pushed on the left side. So I'll make sure I first calculate how much is 5 degrees to the right. So 5 degrees to the right, how much do I get? 005 plus 05, I get 010, 10 degrees. So I know that I have to fly a track. I have to maintain a heading of 010. It is just my heading, not my track. So what do? I adjust my heading from 005. I increase it by turning a right to 5 degrees and having a heading of 010. And this way, what will happen is that my aircraft will continue to stay on track like this. Now, this is the definition of drift. This is the drift that they are talking about. Allowable drift. So in this drift, what kind of drift is this, student? Is it port drift or Starboard drift, Manan.
Port drift.
Very good, Manan. Nandini.
The port drift.
Very good. Students, it is a port drift. Why? Because the wind is coming from the starboard side, that is the right side. So the wind is going to push my aircraft off track to the port side. So the drift actually is port drift. But in order to allow for the drift so that we don't deviate from a track, my heading is shifted to the starboard side. That's it. So in port drift, heading is on starboard of required track. This is what confuses people. Students, even I had this confusion when I had just gotten started many years ago. That port drift is when the heading is on the port and starboard is when the heading is on the starboard, but that is wrong. I think Shubhankar is attending 2 lectures, huh? Shubhankar, you are...
No, sir. No, sir. No, the classes have not started yet.
It's 10:30, right?
So the classes have not yet started.
Oh, very good. How lucky for you, huh? I hope you're not bunking, huh?
No, sir. No, sir. I will message you when the class will start.
Yeah. We are almost done anyway. Don't worry. So students, any questions so far? Manan, Nandini, any questions? Suchita, Yukti, Gulshan, Shubhankar, have you understood this? What I'm teaching right now? Give me a feedback on chat or give me a verbal feedback. Manan, Nandini, Jyotsna, Rishi, think. See, Rishi, Jyotsna, have you done any topic related to these points? Think, share on chat. Everybody has to share something on chat, what I'm saying. Manan and Nandini, tell me. Any doubts, questions that you can discuss directly with me? Manan, Nandini. Achal, I need acknowledgements. Achal, I need timely acknowledgements from you. Please, it's very important because it will really help me focus on your individual growth. Students, understand your videos are off. I need acknowledgements. Yes, Manan, go ahead.
Yeah, sir, no doubt, but it would be helpful for my exams.
Of course. We're just getting started. Of course.
Sir.
Yes, Shubhankar.
Sir, I've understood that starboard one, but port drift heading is left of RT. That one I couldn't understand.
No, that is wrong. That is wrong. That is nothing to understand. Here we think that the aircraft is on the left of the required track. So sometimes that can be confused as the heading on the left of the required track for port drift, which is a wrong thing. So what happens is, although in this case, this happens when the wind is unpredictable. This happens every day. This can happen every day. For you to understand what is drift, this is not drift. What is this? This is track error angle. So this is not drift. This is track error angle. Angular error in your track. How much is the angular error here? 5 degrees. 5 degrees on which side? You would say 5 degrees on port side. But that is not drift. Drift is the one in yellow. This is correct. Are you understanding what I'm saying, Shubhankar?
Yes, sir.
Yeah. So what I'm trying to say is something you might not have had the confusion, but I'm saying this is where some confusion happens. You will not have the confusion, so don't worry about it because I've clarified it already. Earlier, we never focused on clarifying it first. We were just teaching nicely. But later on, I realized that it's not the student's fault. I should clarify it right away. So don't worry, Shubhankar. Okay, so Sushita is asking, sir, how did you shift to 010? All right, very simple. Take it easy. Even if you don't understand, after I explain, put it in your parking lot. Okay, all right. Just saying, because we'll be running short of time. Okay. Directions. No problem, Shubhankar. Directions. What do we say? Yeah, directions. Now, what do we know about directions? Directions are measured clockwise from reference north. What? Write it down, everyone. Directions are measured. This is a very important, the most important fundamental. Most important. Directions are measured clockwise from reference north. Directions are angular measurements. Okay. Example, north is 000 degrees. Directions unit is degrees and are always written in 3 digits. Remember this. Okay. Whenever moving or turning clockwise, students, these points that I'm giving you in one point, if you're thinking how to make notes, then make it in one points and leave a line. These are all rules of thumb, principles. Okay, so just one line will be self-explanatory. You don't need an independent topic. You already know the topic, earth and directions. You already know the topic, general navigation. You already know the topic, navigation. It's like that. So whenever moving or turning clockwise, directions increase or are added. Next point, whenever moving or turning anti-clockwise, when I say clockwise, in the bracket right above, in the above sentence. When I say anti-clockwise, in the bracket left. That makes it much more easy. Right or left, simple. So clockwise means right and anti-clockwise means left. So whenever moving or turning anti-clockwise, directions decrease or are subtracted. So now, example, if required track is 005, okay? If drift is 5 degrees port, okay? Find heading. What will be your heading that you will maintain? So why are we talking about heading? Because heading is one element that is in easy control of the pilot. If you can manipulate something, then it is your heading. Of course, you can choose any heading. A pilot has the liberty to move anywhere between 0 to 360. So what is happening now? How do we find it? Now, Suchita, focus carefully. Everyone focus. I'm teaching it. You just need to focus. Okay. Make sure everyone focuses on this point. If you can get this correctly, then your chances of making mistakes would be very less. So drift is 5 degrees port. Now, Suchita, you tell me, if I don't allow for the drift, then what will happen? My aircraft will be pushed to the port or not? Yes or no? Suchita, I'm asking you. Yes, she's saying yes. Very good. So your aircraft will be shifted to the left. So what is the strategy to make sure we don't get deviated? We move in the opposite direction of the deviation that is going to happen. So if I was going to go to the left, what do I need to do to allow for the drift and make sure I'm on the track? Which side should I turn? Should I turn on the left or the right, Suchita? To the right. Now, what do you do when you turn on the right? You add directions because directions will increase. So what do you add with what? Simple. Heading is 005 plus 5 degree port is equal to 010 degrees. Do you understand this, Sushita? That's how simple it is. So the value that you are going to deviate is the value that you need to correct. That's it. So that value you will get from your computers. So I'll show you. So this is a CX3. You will be required to have a physical CX3. I hope everyone has. I hope, Manan, you have it for the exams. Make sure, Manan, you're also carrying a CX3 as well, along with a scientific calci also. Okay. Both are required in the examination. Not just allowed, but required. Otherwise, we will not be able to do our numericals. So this is your CX3. There are toggle buttons. You see, there are 5 columns. 1, 2, 3, 4, 5. The center one is 3, I would say, simply to help you figure out the keys verbally, because I cannot show you the cursor on the screen. And every column or every row, I won't say column, sorry. Every row has 1, 2, 3, 4, 5, 6, 7. 7 columns, so 7 buttons. So I'd say the left or the row 1, third button. Row 2, third button. So I'm talking about row 3, first and third buttons, arrow buttons, up and down. And the second button, orange button, is enter key. So if I move up and down, see, I get many options for calculations. Wind correction. Click on wind correction. You will get your drift related solutions. What should be your wind correction angle? Okay. Now this here, find heading. You found your heading. Very simple. Okay. There are formulas also. People who don't do logical understanding and knowledge, you will see many instructors giving you just thumb rules, formulas. If drift is port, then heading will be this plus this. If drift is this, then heading will be this minus this. But I don't dislike the strategy. That strategy is for quick revision. That is not for studies. For studies, you understand, and then you go through those formulas, little bits and pieces and rhyming words to make sure you can revise quickly. But these days, what is happening? People are directly giving shortcut to students. And in case of exams where difficult questions are asked, or if repeated questions don't come, then you are unable to give the correct answer because you have not learned to give correct answers creatively. You have just been taught to do something like plus and minus and formulas. That will not help you all the time. So there are many ways it will be done. Many places it will be written other way or other way. But if you understand it the way I'm showing you right now, no text, no language can confuse you because the reality won't change. So whenever you're doing self-study, let's say somebody goes to Europe, somebody goes to Australia, somebody goes to Canada, you'll come across different texts, different languages, but the element would be the same. So you understand the element. Afterwards, even if you'll read a French text, you will understand with translation. It's like that. You won't even need a text to understand this. So what I'm trying to say right now is required heading is this. Find heading, or we could say required heading to stay on required track. This is the actual meaning. Find out required heading to stay on required track. How do I find my required heading? So if drift port heading is equal to required track plus drift, like this. And if drift is starboard, then my heading is equal to required track minus drift. So this becomes the formula, easy formula to use, but not without understanding. Please, students, don't take shortcuts. It is not foolproof in aviation. It will come back and bite you in future, and you'll have to study again and invest time and money again, which is unnecessary. So what I'm trying to say right now is that in order to come to the required correct heading in event of a allowed drift, we can find WCA, that is wind correction angle. After finding wind correction angle, simply add if drift port or simply subtract minus if drift starboard. Therefore, WCA, write down example, wind correction angle plus 9 degrees means turn right by 9 degrees. Example, if wind correction angle is minus 5 degrees, it means turn left by 5 degrees. Why? To get required correct heading. So although I am not talking about WCA, initially I didn't say about it, but you already were able to find out the correct heading. Now I'm saying WCA, still you will be able to find out the correct heading. These are just terms. It's the same thing. Okay. So means turn left by 5 degrees to get required correct heading. Now let's do a numerical. Okay. A very easy and simple situation I'm going to give you all. One, okay, Delhi to Kolkata. Distance, let's say 1200 nautical miles. Okay. Ground speed, we'll talk about ground speed, what it is, how it is later. But this ground speed is what we calculate during flight planning phases. When the aircraft is actually flying, what we read is true airspeed. Okay. So during flight planning, we have to have ground speed. We assume that this is the speed to travel on ground to reach between Delhi to Kolkata in the definite period of time. That's how we calculate it. Okay, so let's say distance is 1200 knots. Everything is hypothetical. Okay, let's say distance is 1200 knots. Ground speed, let's say, is 250 knots. Okay, then your true airspeed, TAS, true airspeed, let's say, is 245 knots. Now, Manan, if my ground speed is 250 knots and if my TAS is 245 knots, then do I have a headwind component or a tailwind component or a sidewind component or a
Tailwind
crosswind
component.
component? Okay. Think about it. Tailwind or headwind?
It would be tailwind because ground speed is greater than true airspeed. So it would be 5 knots much faster.
Okay, think about it. Go through your notes. Nandini, same question. What is the component, headwind or tailwind? Student, lecture time is done, but just stay with me, okay? Yeah. Sorry?
Even I think it's tailwind.
Okay. Rishi, you are saying Edwin? Any more answers? Sushita, anyone, any guesses, calculated guesses? Think. Manan, cross check, revise, see. Can you get access to your notes? Nandini, cross check, Rishi, cross check. I'm getting different answers. Jyotsna, Anchal, no inputs. Gulshan, any idea? Yukti, Suchita, any guesses? So, Manan, I'm waiting. Response. I'm asking you to cross check. Nandini, asking you to cross check. Response. You'll tell me whether you have still have the same answer or different answer.
Yeah, the same answer. It would be tailwind.
How? Justify.
Sir, because TS is 245 and the
No.
ground speed.
Explain the thumb rule, Manan. Don't explain the math. The thumb rule. What's the thumb rule? It's simple. It can be either one of two things. TAS is ground speed plus minus headwind or tailwind. Tailwind will add speed. Headwind will reduce speed. But with respect to what? Ground speed or TAS? So let's say your ground speed is 250. Sorry, Nandini, say again.
Headwind.
Exactly what I'm talking about. Think about it, students. Think about it. So students, what happens? So this is A and this is B. Okay. I want to fly in this direction. Let's say I want to fly in this direction. Okay. Let's say my true course. Now course means required track only. Course means what is the required track that you're going to fly. Sometimes it can be just one direction or sometimes it could be changing directions. So my true course, let's say, is 0900. Okay. Let's say my wind speed and wind direction, let's say, so this is what I wanted to know, what do you think is the value of the wind here and direction of the wind? So what happens is when I make a flight plan, I make my ground speed and my ground speed is what? My ground speed is 250 knots. This is what I do during flight planning. Manan, remember. Okay. And Manan, try to see, don't rush. Okay. If you can, you should know where your notes are, where you have written what. You don't need to go through all pages to find one thing. You should just try to look at, maybe I did it in lecture 1, 2, 3, 4. So you just check notes for that. We have clearly written down headwind minus ground speed plus minus headwind or tailwind will give me TAS, or TAS plus minus headwind headwind or tailwind will give me ground speed. This is what your justification should be. Or your justification should be that, sir, a headwind will reduce my TAS and a tailwind will increase my TAS. Simple. So then you say here, my TAS is reduced, so it's a headwind, not tailwind. So you're trying to prove the math of 5 knots, but the logic was not applied. So the explanation is incorrect. So you understand, Manan, this is an area that we have figured out that you have not done correctly. 1 point of major concern, Manan. You have to fix it. Check. If you still think your answer is correct, justify. Go through Oxford, go through your notes, show me. Simple. Got it? So students, what happens? What is headwind and tailwind? So my true course 0900 means I have to fly, again, cardinal points. This is 0900. So I'm flying in 0900 direction. So my ground speed is this and my true course is, my ground speed is 250 knots and my true course is 0900. Okay. Now my wind vector, although I can anticipate, in this case, I can directly tell you because I've given you ground speed and TAS also. What is headwind? One second, okay, no problem. Any wind coming and hitting the aircraft on the nose or the head. This is headwind. In orange that I made, this is the headwind component. What happens? The headwind component will tend to resist or oppose your forward moment. So you want to fly at 250 knots. Ground speed is 250, so you're maintaining 250. You will maintain what your ground speed is as your TAS. Okay. If there is zero wind or nil wind is also called as still air. Air that is still or nil wind. Many a times atmosphere will have no winds. Okay. Most of the times we will always have winds. So if I'm getting a headwind component, it will reduce my TAS because of the opposite force, like this, resistance. So what happens? This is my aircraft flying in 0980 as per the diagram A to B, and I get five. I won't say the value, but of course the difference between the two is 5, so I can say 5 knots. This wind is coming from here, so it is reducing my ground speed by whatever the value. The difference is the value of this wind speed. Okay, so if the wind speed is 30 knots, then my TAS would reduce from 250, that is ground speed, 250 minus 30. So whatever the value of your headwind, you minus that from ground speed to get your TAS. Remember that. So see, Manan, even I was confused. Thumb rules, I really like to, go through the list every time. But sometimes you remember, sometimes you get confused. So how did I sort my confusion, Manan? Even though even Nandini said the same thing, because I was trying to go ahead with the logic and think about the logic. Students, this really helps us clear all exams. This is my personal strategy, whether I know something or not, whether I directly know something or not, I spend some time with the question. And whatever initial answers I get, if they don't sound right, I don't take them. My mind also will give me a lot of answers initially, but if I don't find them right, I don't take them. I try to keep thinking about the correct answer or the logic behind it. As long as the logic is not understood, I will try not to come up with a direct answer. And that is the secret behind my success in and whatever I have, achieved when I say scoring good marks and, scoring ranks and this and that. It's easily a piece of cake because aviation is a very limited field. It's easy for someone who can be dedicated. It's like that. Now, what about tailwind? Tailwind is this wind coming from this direction. So opposite. So this direction is not, it is coming from north. Wind is when it is coming from north, not north, east. This is going to east. Wind is coming from east. This is going 0980. Wind is coming from 0980. So they both have the values. So my wind vector here I'm giving you, if I give you wind vector 0980, it means it's coming from 0980. It's a headwind. And how much is the speed of the wind? It will be 5 knots. Why? Because here already given the difference between the two is this. Now there is a magic also that is going to happen when we put in only a few values in the CX3 and don't put the other values, still we'll get all the same values in the question. We can try to do that with missing out this thing first and the other thing first, but still we'll get the same answers. Okay. If this is the wind component, 5 knots, 0980, it means 0980 and you are 0980, it means it is a headwind. And headwind, 5 knots, it means it will reduce my ground speed by 5 knots. So my ground speed was 250, it is reducing my TAS to 245. So if in order for me to maintain my airspeed as 250, the pilot will have to fly a speed of 255 on the airspeed indicator. So when the pilot is flying 255, then the 5 knots headwind will put the pilot at 250, and then that the pilot 250 is the required speed to fly. So the ground speed is actually the required speed to fly. Are you getting it, students? Nobody is going to explain this in these basic terms. No one. Nobody has this clarity of understanding these concepts. People rush. And then people who know they are busy flying, they cannot teach. It's like that. So you understand and you make the most of it, students, because this comes with experience. If you can learn and remember this now, you'll really score above 80s in your first attempt of navigation. Above 80s in your first attempt of navigation. It's a sign of a strong student pilot. So last but not the least, wind speed, wind direction done. So what will be my heading required in this case? Is there any correction? What do I do to make sure that I stay on my true course, which is 0980? So what do I have? I have ground speed, check. I have task, check 2. I have wind direction and wind speed 3 and 4. They're independent elements put together, 4 elements. I have like true course 5, and I need one more element, 6th element, which will be heading. And the heading is also referred to as true heading because all these directions are true directions. Why true? Why not magnetic? You will learn very soon. So what is the heading? This is what the pilot needs to find so that the pilot can steer the aircraft. When I say steer, you're basically doing this, steer the aircraft, like this, steer the aircraft. So in case it is a headwind, what are you going to do? Tailwind, what are you going to do? Are you going to do any correction, right or left? Is there any impact to your aircraft? Is there any drift? Do we know? We'll know everything. So what will be your heading? So with above info, find number 1, required heading. Now required heading, I'm just saying for your reference, but people don't use the word required in front of heading. They just say heading. But you have to understand that the heading is also a required heading to stay on the required track. Required track is the term we used much more with the word required. So I'll just put required here in bracket, just put it as heading. Okay, they are not asking about your actual heading. They're asking you about the required heading because of the wind component. Second thing that you need to find out, is there any drift? Third, if yes, which? Fourth, if yes, what's? Wind correction angle. Okay. Is there any drift? If yes, which? If yes, what's the wind correction angle? 4 things we need to find out. Is everyone with me, students? I know I'm stretching it, but don't worry, we don't have any session after 12 o'clock today. So Nandini and Manan, okay, you will be doing a thorough revision and you'll be discussing all your doubts again. Nandini, highlight all your doubts on WhatsApp. Manan, highlight all your doubts on WhatsApp and report how much you have revised today. Nandini, you'll start with your complete revision from scratch. And when you get started, you tell me. And if you want to discuss, you let me know. Jyotsna, Achal, and Rishi, I want you all to do once your revision today for now and discuss all your pending doubts so that when we are continuing, resuming from we had left, considering topics, these things are also important for you. Don't think these are not important for you, but like discussing new topics also when we're learning, that time you don't have any doubts with respect to all that you have learned. Remember, all that you have learned was developing a good fundamental for you. That's why the break between the last lecture and now, mainly, or obviously, of course, we're doing one-on-one RT also, but it was the right time that things happened. So please make sure you revise the fundamentals correctly. Okay, any questions? I'm just checking if Yukti has, I think, disconnection. 5 more minutes. Any questions? Think about it. Manan, any questions, doubts? Are you agreeing with the answer, or do you still think your answer was right? Tell me. Jyotsna, tell me. Go ahead, Jyotsna, first with your question.
So while solving the questions from Heath and Williams, we have some of the questions.
Say again, while solving what?
Heath and Williams sums of
Keith and Williams sums. Okay, yes. Yes,
sums,
yes, yes.
PXP sums. So in that WCA, if it is positive, then I thought I'm thinking that I have misinterpreted it wrong. So if we are turning right, then it is in minus. And if we are turning left, then it should be in positive. I might be wrong. I just wanted to clear this confusion.
No, see, earlier I gave you all right. If you're turning right, then your wind correction angle will be plus only.
So while solving those questions, we have to take plus as the left and minus as right. Then only we are getting the answers.
I'll tell you why that confusion. You share that question with me. I'll tell you why that confusion. Don't worry.
Okay.
That is one confusion, how plus and minus is used to represent a certain value. And that is opposite to the normal plus and minus. Okay. So you share that with me, the exact question. I'll discuss that. I'll clarify that. We'll see this. We'll correct it. If this looks wrong, then we'll correct it. But I understand what you're saying, Jyotsna. Share that question with me. Okay.
Oh, okay, sir.
Yeah. We'll see about this wind correction angle. We'll see. Don't worry. We'll see. CX3 is there. Yukti, can you hear me well? Yukti, are you there? You're on mute. One second, students. Yukti, are you there?
Yes, sir, I'm having some problem in my network, so
No problem. Just I think we'll make it. This is last. Just focus here. So we have a question. We have values. These are the values. We need to find these things. This is the gadget that will help us find these things. In this gadget, this is the option, wind correction. Enter. Just feed in all the details. Half of y'all already have practice with CX3. Freshers, don't worry. I'll teach you everything about CX3 from scratch in time. Okay. So put the ground speed in knots. How much is the ground speed? Simply put in the values 250. Press enter. Check the unit north. Check if the value has come in green. Next, what is my TAS? My TAS is 245 knots. Enter. What is my true course? 0900. Enter. What is my true heading? I don't know. I need to find it. What is my wind speed? I know 5 knots. What is my wind direction? 0900 knots. What do I get? Check it out. Do I have any wind correction? Do I have any drift? No. Do I have, what is my new heading? My new heading is the same as my true course, 0900. So I don't need to change my heading. It means I don't have any drift. Simple. So I don't need any wind correction angle. So I don't need any correction. See here, exactly mentioned over here. Can everyone see? Yukti, can you see what we have done? We have put in the ground speed 250 knots. Again, I'll do it in this section of wind correction in your CX3. Ground speed 250 knots. Enter. Make sure the green has come. True head speed 245 knots. Make sure the green has come. True course 0900. In the calci, it will be 2 digits for 2 digit, 3 digit for 3 digit. But you'll also always write 2 digit also in 3 digits, leading with 0. True heading, I don't know. I had to find it. Wind speed, I knew 5 knots. If you wrongly write something, there is a backspace key also. First row, 5th button is the backspace key. First row, 5th button below the C, Charlie. Wind direction is also 0900. Enter. So you see, what's your true heading? Found out. My answer number 1 was, see, so easy now. So your general navigation, actually, if you understand the logic, then you don't really have to study much because you have your calcs with you in the exam. That's the secret. That's the secret, you know. So answer 1, required heading, same as track, 0900 degrees. True. Answer 2, is there any drift? No. Why? As heading and required track are same. So no drift. It's the same. I found out the wind is not impacting my heading at least. Good. It's only impacting my speed. 3. If yes, which? No. It's not applicable. Only third question. 4, if yes, what is the correction? Not applicable. No, because point number 2 is not there, so 3 and 4 will not be there. Okay. Now let's do another one quickly. It's easy. Students who don't have an access to the digital CX3 like I'm using right now to practice, please request for the same on WhatsApp or email. WhatsApp, generally I'm sharing the link so that students while studying can use the link on the phone and use it as a CX3. Simple. That's why. So I'll share it on WhatsApp. Let me know. You can practice. Let's do question number 2. Okay. Give me any values. Anyone. Manan, give me a true course.
Two seven zero.
270. Okay. Achal, give me a ground speed. Achal is giving me 210 knots. Okay. Yukti, please give me wind direction. Any value from 0 to 360. Come on, fast students. We are stretching our time. 115. And Rishi, give me wind speed.
35 knots.
35 knots, you mean? So wind direction is 15 degrees at 35 knots. Thank you. So 4 elements are done. I need 2 more elements. What are, so there's a combination of 6 elements. This actually makes up your wind velocity triangle. Okay. I have not mentioned wind velocity triangle, but it's a part of your in-flight navigation and your flight planning. In this list, one important element was missed to mention in this list. Let's add it. So here, flight plans. Here in flight plans, you have velocity triangle also. Velocity triangle. Velocity triangle has these 6 elements. You will learn everything. I'm hoping those who have learned are doing thorough revision right now. And afterwards, you'll also do self-study and thoroughly revise these points and discuss doubts. You have to get back to me discussing your doubts. Of course, I know your timeline, so I'll be solving your doubts based upon your timeline. Even though I'm not solving it immediately, if you need immediate solutions, you'll tell me, sir, I need immediate solutions because I'm stuck. Of course, I'll then give you immediate attention. So let's go continue. Manan, Achal, Yukti, Rishi done. Jyotsna, wait, okay, Jyotsna, stand by. Heading, TAS, drift, wind correction angle. Let's see if we can find it all out. Okay, we only have 4 elements. Let's see if we can all find it out. Students who want to try using CX3, immediately you can ask me for the link even now. I'll share it immediately. You can also practice on your own. I hope everybody else is also practicing with me right now. Don't just observe, you also do it. Press the buttons and do it. I think everyone has it apart from Gulshan. 1 second, Gulshan. Sharing. 1 second. Copy. Where is it? Done. Going to wind correction. Take it easy. Play with it. Eventually, you'll know what is where. Okay. So go into wind correction angle. Press C to make everything that you had done earlier go away. Charlie, number 4 in the first row. Now let's put the values. My ground speed is 210. Sorry, students. My TAS is not given to me. My true course is 270. My true heading is not given to me. My wind speed is 35 knots. Actually, 35 knots, we can say heavy winds. Not very heavy also, but heavy enough. and wind direction is coming from 115. Do you think you get it or not? Let's see. Press enter and look at the magic. You directly got your heading. What was your heading? See, just read out the values. Simple. Your heading is 265. So this is what you need to maintain to stay on the true course 270. So if 265 is what you have to follow and required is 270, so simply make a sketch. Now be very careful. Jyotsna, you also be very careful. First make a cardinal point like this, a diagram for cardinal points. Then true course 270. This is 270. So you get a brief idea that this line is my flight path. You're flying in this direction, this line, anywhere on this line, you get an idea. When you make a cardinal point, you firstly make cardinal points and track your true course first. That is fixed line that you have to follow. So this is 270, this line going in the west direction. Okay. Now your heading is 265. So where is 265? Remember, the first definition of directions are clockwise measured from the right, clockwise from north. So your directions keep increasing from 0. So 265 would be somewhere here. 265 and this will be 270 like this. So this is what you need to be able to sketch. This is what you need to be able to master. If you do this, nobody can defeat you in general navigation. No examiner, no questions whatsoever. No interviews also, no real life situations also. This is why even captains and not just fleet pilots, fleet captains, they use this strategy. It's the best strategy to make quick decisions and accurate decisions. Now tell me, if my heading is on the left, now with whatever I've taught you about port, if I have corrected my heading, now it is required, it is anticipated drift. Imagine, it is not the confusion TMG and all. So if my heading is supposed to be on 245, in order to be on 270, then what is my drift? Is my drift on port or starboard? And by how much value? So the angular difference between 270 and 265 is 5 degrees. And I as a pilot have adjusted my heading 5 degrees to the port. So my heading I have adjusted 5 degrees to the port. When will I adjust my heading 5 degrees to the port? When I have a similar amount of drift in the opposite direction, to the right. Another way is that my heading 265 is on the left of 270. Now you focus on the direction of your flight. Your arrow is going there. So the left is this and the right is this. This you need to imagine correctly. So if I made my heading on the left of the required track, then you go ahead with this definition. I've given you 2-3 different ways to understand what is drift. Choose any one. Heading is on starboard. I have port drift. It means if heading is on port, I have starboard drift. Everybody agrees with me or not? Anyone confused? Quickly ask, because we are about to wrap up now. I don't want you going, like staying home after closing this session. I don't want you all to have any doubts. Take your time, discuss, but make sure you have understood it. So what happens? I have to turn left 5 degrees for a new heading, that is 265, to avoid my 5 degree drift, which would have happened on the starboard side. So what is my drift? My drift is 5 degree starboard. And what is my wind correction angle? I have to turn left. So it will be minus. By how much value? Same value as drift. So minus 5 degrees. Check in the NavCalc. I've got minus 5 degrees. Minus means always left. Plus means always right. Simple. Final thing. What is my task? If it would have been a headwind, tailwind, calculating my task would have been easy. It's not a headwind, tailwind, but good for me. My CX3 has already solved it for me. I'll check, and my task is 178.89er. But if I plot the direction of the wind, 115, where is 115? Clockwise, 090, 010, 115. This is 115. Okay, this is 115. So where is the wind coming from? The wind, let's make our aircraft. Now let's this go away. Where is my aircraft? So earlier, this is my aircraft. Okay. When I realized that I am facing wind, wind from where? Wind from this direction, like this. This becomes wind coming from 115 at 35 knots, like this. Generally, these bands show you the value. You will learn this in meteorology pretty soon now, because we are going to do winds anytime soon, because our basics are over. Most of you all have done it. So that is the wind. So if the wind is coming from here, your aircraft earlier was assuming a still air condition, so the heading and course was the same. Now, because of this wind, I'm going to be drifted there, but my calci is not showing me the drift. My nav computer is showing me that simply correct your angle 5 degrees to the left, that is minus, correct your heading and go on a heading 265, and automatically you will stay on track. So what is my pilot doing here? My pilot is just, instead of this, so what is my pilot doing now? What is happening to my aircraft? Imagine it clearly, okay? My pilot is just steering the aircraft. When I say steering, it means you're maintaining the CG. You're not moving your actual location. You're just moving your heading. That is called steering. When I say steering, like I'm on a chair, my chair, I'm not moving, but I'm just moving about my own axis of the chair about the CG. So this is how you steer in the aircraft, not your cockpit seat, but the aircraft steers about the CG. Okay. You might be thinking, so what are you saying? Is the cockpit seat like this? I'm like, no, it's a very rigid seat. But of course, cockpit seats can go ahead, come back. I think they can lift and go down also. Like that adjustment obviously is there for different sorts of height and weight and body of male and female pilots similarly, you know. So what do I do here? Final thing, based upon these calculations, what will happen? How would my aircraft look like ahead of this situation? My aircraft will look like this. Heading would be 260. Now, where is the CG? If you're wondering, I'll also plot the CG carefully on this aircraft so that you see how it is. And this is what I will be doing. And I'll continue doing this for as long as I need to reach from point A to point B. And this is how I'll be flying for the rest of my flight, for as long as this wind is affecting me. Only for as long as this wind affecting me, same direction. If the wind value will change, changing winds will require you to keep changing your wind correction angle also. So this is the art of in-flight navigation, and your radial, DME, VOR, radio navigation, in-flight navigation, sums are based upon these concepts only. So even in radio navigation, your basics are still general navigation. The only difference is right now you are not talking about radio nav aids. You're simply using a true north. There our reference would be certain destinations. So when we have those destinations, we will have relative bearing with respect to ADF and radials with respect to VOR. That's it. So this is what you are doing now after this calculation to make sure you stay on the required track so that you can safely reach to your destination. Jyotsna, does it answer your question? Doubt? Now only concern is, what were the questions? Is it a complicated question to understand? Is it a misprint? Or is it something else? I'll tell you. But so far what I'm telling you, do you think it's right or wrong? Tell me, what do you think? Jyotsna, I'm asking you.
Yes, sir, it's right. I understood.
Sorry?
I have understood it. It's right. And the
Yeah, but
confusion is also
quickly share that KW with me, okay? KW thing. Don't delay.
yes, sir.
Yeah, very good. All right, students, that's it. Achal, tell me, what have you understood? Victor Tango Golf, India Zulu. Can you give me a verbal response? Okay, fine. Achal, on your feet, I need your acknowledgements faster than this speed. Try. It's good you are giving. I'll need more instantaneously. You can just say yes and go ahead and then write everything else. That makes sense. That will increase. That will know that you are typing the other answer. That will take time. Instant, you'll be like yes, and then you can go ahead with your answer. Good. I just need instant acknowledgements. I want you to have a habit of that. I know typing takes time. That's why the delay. But instant in typing, if you want to prefer, then instant you give me yes something and then write your complete thing. Good. Very nice. Okay. Rishi, understood? Doubts?
Yes, sir. Understood. No doubts.
Very good. Anchal is saying it was a good revision. I'm very happy that you feel that way. That is the whole purpose. Jyotsna, how's it going for you? Any doubts? Good. Very nice. Understood everything? Okay. Gulshan, how about you? Understood everything? Any doubts?
No doubt, sir.
Understood?
Yeah, yes, sir.
Wow. How do you feel? Do you feel nice?
Yeah, it was pretty good, sir.
Had you studied earlier these things?
Yeah, yes, sir. Like I have studied about these directions and all, so it was easy for me to understand.
Very nice. Keep it up. No questions?
No questions.
All right. How about you, Suchita? No doubts? No questions, Suchita? Suchita, she's just texting as she understood. Good. Okay. Nandini, how about you?
Understood, sir.
No questions?
No, sir.
Yukti?
Yes, sir. No doubt, sir.
What about disconnections? Did you miss anything?
Yes, sir.
But I tried to cover it again when you joined. I was waiting for you. Whenever you had disconnection, I was not teaching anything. So whenever you got back, whatever I thought, were you able to keep a track of that?
Yes, sir.
Any doubts?
There's something like I haven't written something that
What?
I will ask you later.
No, now only. Ask
No,
that
sir,
now.
I understand everything, but I haven't written this question 1 and the above notes.
Why not? Why didn't you write the notes?
Because of the network issue.
No problem.
So,
No, but it's okay. Take it easy. You're just getting started. No problem. Fine. See, you can take a picture of this if you want. Take a screenshot or something. This is the first question. Solve it again. Okay. Manan, coming to you, Manan. What's happening? What's your status? Did you understand? Do you have any questions? Students, when I'm discussing other people, you can go through your notes, revise, see if you have any more questions, or listen, be a part of the discussion, right? Yeah, Manan, tell me.
Yeah, so understand. No doubts.
Manan, you and Nandini, Aanchal, Jyotsna, and Rishi have to talk more with me. Main priority is you and Nandini in sequence. So you all cannot do just with yes and no answers with me. If I'm asking something, you have to upfrontly give me every information that you have got about the topic in your own words. Are you getting me what I'm trying to say? So so you finally tell me everything, an overview, Manan, all that you have understood. Go through your notes nicely in your own words. Do it. Now, live. And Manan, you were wrong about headwind, tailwind. What about that? Why the confusion? Please explain.
No,
Talk.
sir, I was in hurry because I was my concept was clear, but I was in hurry looking at the.
It's okay. It's normal. We will.
So,
It's a
so
common
then
mistake. Uh-huh.
so it
But
took me 5 minutes for understand and everything to recollect, and
I
then
was giving you all hints.
yeah.
Still, you were sticking to your answer. When somebody gives you a hint, say, okay, let me verify. Let me
Then
verify.
after I verified.
Yeah. So you got the verification. Share that with
Yeah,
me.
sir. Yeah.
Share that with me. Make sure you don't get this confusion again. If you're confused once, you can get confused again also. All these things you've revised today only. Nandini and Manan, Anchal, Jyotsna, Rishi. If you have studied topics related to these, revise all thoroughly. And towards the end of the afternoon, towards 5 o'clock, report. Generally, students, if you don't have live lectures till 5 o'clock, you still study till 5 o'clock. I give you a lot of things to study. You have a lot of tasks. I've asked you to stay in touch. But that doesn't happen much, Like, I don't like bothering students directly, that will make the students run away from me in the long run. I don't like that. That will prevent you from learning the best from me. So I tell you all to reach out to me, to develop a habit to reach out to me first thing, and that habit is very important for you to ask doubts. But I see that as a challenge with almost everyone. Almost everyone. Not everyone, almost everyone. That's the difference between the ones who would take more than what I'm giving and others who would take less than what I'm giving. So it's up to you, students. If you follow my strategies and if you follow my instructions, it'll only benefit you. I cannot force feed you, right? I can only share and guide. I cannot shout, right? I don't like that. I don't like to beat and teach. I want to explain, give you your time and understand. All right. So that being said, so good, very good, Manan. Any doubts? Anything else? Was it a good revision? What all points did you revise? Tell me, Manan, give me a brief.
The whole overview of the general navigation, what to revise and what topic is left for me to revise, and this drift and all cardinal points. What is drift? What is plan track? Track made good and everything. It was a good revision.
A few more points. Keep thinking, keep speaking. See, you also learned about drift, port drift, starboard drift. You also learned how to find out the drift. You also learned about wind current. See, I need these key points, Manan. Come on, it's there. Just speak it out. Everything is there. You have written it down. Just speak every point, brief keyword. Just say, okay, this is this, this is this, this is this. Are you getting it? What I'm trying to say? Why you're missing out on those points? Have you not made notes, Manan? See, this is what I'm getting angry about, when students are not doing what I'm asking you all to do, and your videos are also, so you're taking all the benefits and you're not giving what you're required to give in return of those benefits. Then there is a mismatch. If there is a mismatch, then there will be a mismatch in the results also, right? Expected results. So you don't understand. If you don't follow, if you don't do, chances are that you will not clear. So don't mess. Try to do it. Manan, just read out all the points, man. Come on, you're not covering all the points, not covering all the keywords. Tell me why if you're not doing it. Tell me, sir, I've not written it. Can you help me? Can you share the white? I can easily share the whole PDF of the whiteboard in a second to you all. Come on, but you need to tell me. You don't need to ask me for that. You don't need me to ask you how much you know. A good student will always say, don't worry, sir, I'll take care of it. सब समझ गए तो मैं नहीं समझा तो मुझ में गलती, आप में गलती नहीं है. No, I don't like that. तुम नहीं समझो, तुम्हारा देखो बस. तुम मुझे बताओ. मैं या तो लाइव क्लास में समझाऊंगा, नहीं तो वन ऑन वन समझाऊंगा. But understand, it's not just a group session, it's a one-on-one thing. So Manan, one last chance. Overview covering all keywords. It's something that is new that you're learning and you have to do. Come on. Keywords, come on. What else have we covered? Keywords.
The hexadecimal rules, like where's the true north, west, east, everything. Then like starboard drift, port drift, from where the wind is coming. So what will be your track and what will be your heading? Then if you do not compensate for wind, then what will be your track made good? The difference
Very
between
good.
track made good, drift,
Very
heading,
good.
everything.
Very good. This is it. Now you don't have to say everything else because this is it. Now you have got it. Very nice. And whether you know it or not, when I'm saying that you give me an acknowledgement and you do it, it will only help you and it will build that confidence and we both will be on the same track and I'll keep your preparation in check. Got it, students? Very nice, Manan. Good job. I like it when someone I push does it so quickly. It's not easy, I know. Manan, well done. Superb. Superb. Keep it up. That way only you can continue the answer saying, so if you're talking about allowed drift, if your heading is on the left, then it's actually starboard drift. Okay. And the wind correction angle actually have done is on the left to avoid the starboard drift. Simple. That is one more thing that we studied. And about sexagesimal system, today I've not used the word, of course, but clockwise measurement of directions from reference north is sexagesimal system. So the other point, 2 more points you would have said, bang on, perfect revision of what we have studied in class. When you revise towards the end of the session, what you have studied in class, students, one revision gets done there and then. The next revision you do day after, same time or somewhere around. It's a scientifically proven strategy of when to do revisions. Once in the next day, same time, once I think next second week, same time, and next after 30 days, same time. You just do timely revisions in these 3 occasions, automatically you store everything in your long-term memory. I don't know, I just keep giving strategies. People who use, they clear. People don't use it, they struggle, eventually they clear. Up to you. If you don't understand, keep discussing, keep asking, but make sure you are proactive and interactive. Okay, students. Nandini, what questions, ETA questions, do you have any questions? Can you share with me those questions?
Yes, sir.
See, ETA is nothing. I'll just tell you, it's very simple. Okay. What is ETA? Estimated time of arrival. Okay, what is the estimated time of arrival? Now, what happens is when it comes to time, there are 2 things. First thing, your duration of flight. Okay, let's say duration is 10 hours. Okay. Second thing, time zones. If you are traveling from one time zone to another time zone, although your travel time will still be 10 hours, the time, if you take off at 5 a.m. in the morning from one zone and travel 10 hours and go to another zone, ideally your mind would think that after 5 in the morning, 10 hours is how much? 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3. 3 p.m. So by your local time of your departure airport, you should be reaching your destination by 1500. That is 3 p.m. That will become your ETA for your local time as per your local time of departure. That is local time. If you're traveling between zone to zone, then the local times will change because of the time difference. So let's say that you're going in a different time zone. So your ETA will not be 150. Your duration will be 10 hours only. ETA will not be 150. If the time zone is different, if the time zone is same, then the ETA will be same. In India, anywhere you go, your ETA will be same. But at the same time, if you want to go to New York, traveling the same hours that you'll be traveling in India, let's say you want to travel in India for 20 hours, but within India only, then you can say 20 hours also go circular, I'll move, my ETA will be the same. You go to USA, 20 hours, 24 hours, whatever time it takes, your ETA will not be the same. Why? Because of time zone. So the time zone would just be what? Plus or minus whatever value is given. And that value is there for all zones. It can also be calculated through a formula. So let's say the zone where we go, the value is plus 530. So this plus 530 will be added to the UTC So first we'll convert our local time into UTC time. Then we'll add this plus 53 to UTC, get a new UTC. That UTC, we will add 10 hours to get our ETA. Then that 10 hours will convert into local time. The UTC 10 hours will convert into local time, and that would be our actual ETA. So this is something that you do in time. We will be doing a revision lecture on it, but please share the questions that you have related to this topic. Okay. All right, Nandini, got it? I've given you almost half the explanation. I'm just not giving you formulas here. Yes, no, maybe. Good. All right, students, that's it. Sorry for stretching it so much, but anyway, you are having rest of the afternoon free. And understand they are not two different lectures, morning and afternoon. Any schedule that you see where you have first half, second half, they are just the same session. It's just that I don't like taking 4-hour lectures at a stretch. It's too much for everyone, for my students. I need to give you all a break. Half an hour break would be rushed for a lengthy lecture. It can get boring. So 1 hour lecture so that you can nicely, go about it. Don't worry. This is deep learning. What is it? It is deep learning. What happens when you join a ground school? Normally, everyone will start with deep learning on your first day. As a fresher, deep learning should not be given to you on a first day. So you will see, apart from Gulshan, Yukti, Suchita, you all have some experience. You have been studying. I think Gulshan also has been studying. But still, for you, it's like an introduction session. For others, it's like a revision session. That's my smartness to conduct a session to account for everyone, But what happens generally, I'll tell you that what we are doing now, 4-hour lecture, 3-hour lecture, generally navigation studies are held not less than 2.5 to 3 hours in every class, regularly every day for 5 to 6 days a week, along with other subjects. 9 to 5 crammed up, 4 hours navigation, 2 hours regs and met. No discussion about art. This is what everyone else is doing. This is not healthy for you all. This is not how learning can happen. The effective learning cannot happen. Only those people who are, very well with textbooks and mugging up, and some people can do it still with that pressure, but long run still the knowledge will not be accurate. So initially, when you start, we take it slow and we develop fundamentals in you, strong fundamentals. Once the fundamentals are strong, then we do deep learning. That deep learning, even you find it very much fun. Okay, nice. 4 hours navigation. Oh my God, it's going to be so much fun. That is the feeling you should get. So we don't say 4 hours, we say 2 hours nicely spread between one break. It is like that, of 1 hour. So when we do deep learning, so today, let's assume we had to continue this lecture. Then we would have nicely taken one break and continued for another hour. We would have had time till 2 o'clock just for navigation. From 9 till 2, just for navigation. Deep learning, clear learning, nice learning. Okay. So make sure you understand the whole logic. And anything else, if you'll need from me, let me know. If things work out, don't work out, if you're liking, disliking, if you need anything extra, if you want to meet me in person and learn, whatever works, let me know. In person learn possible in Mumbai at the moment, one-on-one. Okay. Other cities, let me know where you are. If I'm traveling, definitely I'll meet you all for a session or two and we'll sit and study. Okay. And if you all need more one-on-one sessions online, do let me know. Of course, it's on the cards, but if you want it on priority, then let me know. All right, students, I'll take a leave. Is it okay? Any more questions before I go?
No questions, sir.
All right, then, students, well done. I'll see you tomorrow. Tomorrow, be ready for both sessions 1 and 2. And yeah, that's it. Send me your notes, everyone, after the session. Achal, cover up whatever you missed in the beginning. And that's it. I'll see you all tomorrow. Don't be late. Be on time. Rest of the day today used for revision and completion and sending out doubts to me and discussing doubts with me. Whoever doesn't have these things, rest and relax. Okay? I'll take a leave. I'll see you all tomorrow, students. Take care.
Sir, one doubt.
Gulshan, it's too late. कब से पूछ रहा हूँ डाउट
sir,
डाउट डाउट जाते
sir,
जाते
doubt
कौन
means,
पूछता है डाउट यार? घर के बाहर निकल गया, अब मैं वापस बुलाओगे? मैं तो उबर
sir,
में बैठ
doubt
गया हूँ, क्या
मतलब
वापस
कि
बुलाओगे? I'm
sir,
just kidding with you, Gulshan.
can we
Yes.
start computer number process? Hello.
Gulshan, I
Yeah,
told
yes,
you
sir.
I'll get back to you. You drop
Yeah,
me a
yeah, sure.
message and remind me. Right now, discuss navigation
Sure,
doubts
sure.
related to topic.
Okay, okay. Okay, no doubt, sir, no doubt.
Very good. All that, I'm telling you, na, anything else, drop me a message. Anything else, drop me a message, okay? And doubts, timely, okay? Don't ask doubts when we are going, otherwise it gets stretched a lot. So those doubts, you'll have to put in your parking lot. So Gulshan, computer number, put it in your parking lot. Nandini, ETA questions, put it in your parking lot. Jyotsna, Keith William plus minus WCA, put it in your parking lot. Manan, headwind, tailwind, put it in a parking lot, at least so that you know these are your weak points or doubts or concerns in your mind. This is the whole meaning of the parking lot. Got it, students? Suchita, you can put that parking lot plus minus angular measurements if you're not thorough with it. At least keep your doubts written. Later on, if they're clear, you can just cross it out from the list. Okay. Gulshan, no problem, but these things, just drop me a message. Yeah, I've told you already. Okay. Chalo. Take care, everyone. Thank you for joining, and I'll see you tomorrow. Bye.
Thank you, sir.
Thank
Bye.
you,
Bye.
sir.
Bye. Bye to both the students. First lecture.
Bye, sir. Thank you, sir.
Thank you, sir.
Bye, everyone.